And okay,
Your host.
It is streamed on YouTube as well.
Mm-hmm.
Ok. Tout le monde, ça c'est bon. Ok.
Ah, wait, I need to change this. No, display settings.
Display setting, swap. Yeah, perfect.
Can you see? It's good.
Yeah. Okay, so for the time being, only Andrea with camera on and microphone on. And good luck to everyone and see you in a bit.
Good luck to everyone.
Ok, je te donne la green light une fois ouvert, ok?
Okay.
Alors, je switch en français. Ok.
Tell me also want to start recording, or do I do it already?
Attends un peu.
Ouais.
Ok, moi je commence l'enregistrement. Tu peux faire la même chose de ton côté. Alvaro, if you can switch off your camera for the time being. Ok. Ok, ça monte. C'est toi qui as démarré là?
Oh, maybe.
Bon, c'est bon. On attend un peu. When it reaches 100, you can begin. You can see. Okay.
I can see the participants now, yeah. Okay.
Allez, good luck.
Thanks, Tito.
Don't forget the interpretation guidelines. Huh? I begin. You can begin.
Hello, everyone. Welcome to this Copernicus Marine Service workshop dedicated to the African community. Today, we will have a practical session. Yesterday, we had our first session full of presentations. We introduced you to the Copernicus Marine Service. We had a lot of presentations from our data producers. We introduced you to the Marine Copernicus Marine Service product and data. And we also introduced you to some very interesting use cases. Today, we will have a practical session. My name is Andrea Carvalho. I'm a training officer at Mercator Ocean International, and I will be your host for today. Just before we start, I would like you to know a few things you will need for this workshop. First, we will have a platform throughout this whole workshop and even beyond, dedicated to the e-learning materials. It's called the Padlet, and here on your screen, you can see the link to access the Padlet. There you will have access to the replays of yesterday's and today's session. So if you were not here with us yesterday, you will be able to see that our presentation. You will also have access to the tutorials we will show you today in today's session. And many other information. So you can see the link here on the screen, but I will also post it on the comments. So we are using Zoom to broadcast this session. But for the questions, which we hope you will have many, we are using Slido. And we will also post the link on the comments. But if you go to slido.com and you type this code that you can see on your screen, you will have access to our session. And there is where you should put your questions to our speakers and to us. One very important information about today's session is that you will be able to have live interpretation. So we will be presenting in English, but if you would like to have French interpretation of today's session, if you look at your Zoom window, you will find a button with this symbol here, saying interprétation. You should click on it and you will listen to our interpreters. Great. And after some guidelines, I will introduce you to our speakers and tell you a bit about our agenda for today. So today we will have Cédric Jourdain. He's a user support manager from Mercator Ocean International, and he's gonna be telling you about the user corner, how you can contact the user support, and how you can access some e-learning materials as well. We will have Anaïs Perrin. She's a Copernicus Marine Service officer, and she will give us a live demonstration of My Ocean Viewer. And we will have Alvaro and Stefania. They are both ocean modelers at KnowLogin, and they will give us very interesting tutorials about the Jupyter, using Jupyter notebooks and the QGIS. So I hope you enjoyed today's session. Don't forget to put all your questions on Slido, and we will start very soon. So I will introduce our first speaker, Cédric Jourdain. Whenever you want, the floor is yours. We'll then start.
Yes. Good morning, everybody. Thank you, Andrea.
Thank you.
So I am Cédric Jourdain, so I'm user support manager. I will give you an overview of the user corner, which is an area dedicated to users to handle the service and to have information about products, etc. So you should see the main page of the website. So to reach the user corner, it is in the top menu, user corner. Clicking on it, I reach several boxes, and the first one is getting started. So as it is, as you can see with the name, you can have clues and information to begin with the Copernicus Marine Service. So you have different links to the offer, ocean products, state report, indicators, visualization, and operational path to have links to manage the service. So search, visualize, download, etc. So it is the first page to visit if you want to use the Copernicus Marine Service. If I come back to the user corner section, the second box is a real important box, because it will give you access to the Help Center. In this Help Center, you will find more or less 140 articles about on several topics, on the products, on the services, the download, the visualization, etc. So, for example, you can click on the search area, can give a keyword, and you have the different article matching this keyword. So, for example, the first one, how to download Copernicus Marine products. I click on the title, and I read the article with the menu, the time to read. The menu is as well on the right side of the screen, and then you will find screenshots or videos and step-by-step information to master the service. So this is for the download. If I, for example, not this one, sorry. if you have information about the MyOcean viewer, the MyOcean Pro, which Anaïs will present you just after this presentation. So you check, you type MyOcean in the search area, and you reach the introduction to MyOcean Pro viewer, etc., and the main feature, etc. So this feature, the Help Center, is really, really, really important to have to have important information on the services and the products. I come back to the user corner. The third box is the user notification service. So I click on it. I reach a dedicated page to inform you, users, about the operational events related to product and services. So there are 4 different categories, so general, improvements, incidents, and maintenances. So if I click on incidents, for example, here you will find the list of all the incidents related to a specific product. So you have the status on the right, you have the first date of the date of first publication, and if I click on the title, sorry, I have the details on the incident, the status, and the product impacted. What is useful and important in this page is you can create an RSS feed. For example, you can create your own RSS feed using the different filters on all the free text area. For example, here I will find only the incident related to the product, the global product 124. You can make this view an RSS feed, and you can subscribe this RSS feed to be automatically informed on in case of new delay or new incident on this product. And if I go back to the Help Center, for example, if I type the keyword inform, how to be informed of operational events on the product and services, I click on the article, and you will find a step-by-step to create and to subscribe this RSS feed. Okay. So I come back to the corner. The following box is the user learning services. So here you will find information about on the training and events manager or for the Copernicus Marine Service. So here, for example, you have the link to the marine data for Africa. The box after is related to the e-learning materials. Here you can see many materials which can sort by level, subject, and tool or free text area. And then all these materials are freely available for you, and you can. So it's quite interesting to check this page and to check all the materials available. Up the corner. The next box is the product quality. So this mini site the embedded mini site is dedicated to the quality of the product. So we will find generic information on the quality of the product. You can sort by area, Arctic, Baltic, etc. On the color of the ocean, so blue, green, white, and these pages are dedicated to the quality of all the products. So do not hesitate to check it and to ask questions to the user support if you have any. I come back to the to the user corner. Then there is an area dedicated to the roadmap, which is for this page is currently reviewed to propose information on the future evolution of the product for midterm. So you will have the date of the improvement, the impacted products, and a short description of the improvement. So the work on this page is ongoing, and it will propose information for for example, for information from the November 2023 release or the March 2024 release. But for the moment, so it's ongoing, though you will have only information on the past improvements. Get inspired. Here you will find different examples of application of the different application using the Copernicus Marine Service products. Here you will find the use cases presented yesterday. You can sort by region, by country, or by market. And clicking on the icon, you will find the description of the use case, the product used, and different useful links and the benefits for users. All the use cases are made on the following this sample. So you can submit your use case here. So do not hesitate. You will reach a form to fill in and submit this form to the team dedicated in charge of the use cases. Up user corner. Then the last boxes. The first one is to log in or register. So you will find the registration page. This one, service commitment and license, you will find our commitments on the what time do we need to answer a question, to what are your obligation, because even if the service is completely free, for example, you have to cite the source of the product if you use them in your application. So all is detailed in this document. And the last box is the contact us form, but to contact us, the best is to use the chat platform here at the bottom right. In this widget, you will have a link to the Help Center. You can search the same behavior. You can search here using, for example, a keyword inform. How to be informed. I find again the article dedicated to operational events. And if you are authenticated, so registered and authenticated. So for example, I'm going to log in. No, it's not this one. And when I am authenticated, I have the possibility to send the message to the team. So don't hesitate to use this feature, and you will reach a member of the team, Anaïs or Martin or anyone else. And so do not hesitate to contact us if you have any question. But the first feature to visit and to use, it is the Help Center section with many information inside. So do not hesitate to check this feature. And if you still have any question, do not hesitate to contact us using the chat section. Thank you very much.
Thank you, Cédric. That was very nice. And yeah, now you all know what to do if you want to access data and if you have any questions. We actually have a few questions. They are a bit general, not necessarily about the user corner, but maybe I can share my screen. Just we can quickly answer them. Yes. If I can find my screen. Yes. Do you see my screen with the Slido?
Yes.
Yes, opening. Oh, great. So I think, yeah, you mentioned it already, like, right, like in terms of commercial use
Yes.
of Copernicus data? Is there
So-
any specific rules?
No, whatever the use, commercial or not, the data is free. You only have to cite the source of the data. So everything is explained in the DM Center. There is an article dedicated data policy. So everything is free, whatever the use.
Yeah, exactly. Great. And okay, this one is a bit more specific, but maybe they can search directly on the data catalog as well about what sort of wind products we have available, I guess.
Yes, you can go to the catalog, and though you can specify your search on the specific variable or a keyword, etc. So you will find all the products in the Marine Data Store catalog.
Yeah. And then the next few questions, two questions are about the type of courses we made available for you guys. And yeah, it does include a bit of, well, we have several tutorials like Cedric mentioned already on our website, and you will see there's a bit of modeling and data visualization over there. Then we don't do specifically on that, but our tutorials include that as well. So I suggest you just explore that section Cedric mentioned. And yeah, I think we're good for the moment. Thank you, Cedric.
Okay, you're welcome.
If you
Have
have
a
any
nice
questions,
training.
don't hesitate. Thank you. And now I will introduce you Anaïs Perrin, and she will introduce a very cool feature of our Copernicus Marine Service, which is the viewer. And she's going to tell us how to access the data and visualize the data. Hope you enjoy it.
Yeah.
The floor is yours, Anaïs, whenever you want.
Thank you. So can you see my screen here?
Yes.
Yes, okay. So hello everyone, I'm Anaïs from the user support team of Copernicus Marine. I will introduce you the main feature of the MyOcean Viewer Pro. So to access it, you just have to click on Ocean Visualization here. So you have here three different ocean visualization. The MyOcean Learn, dedicated for beginners, the MyOcean Lite for intermediates, and the MyOcean Pro for experts like you. So I will choose this visualization tool. Here you have
Excuse me,
so
Anaïs?
two. Yeah.
We don't see the
Yes.
right screen, I guess.
You don't see the right screen, okay?
Yeah.
Oh yeah, I also don't see it.
Okay. Okay, yes, okay. So it's good?
Thank you very much.
Yes. Sorry. So you arrived on the MyOcean Pro visualization tool. You have two different layers open on your interface. So if you pass your mouse on the name of the variable, you have access to the name of the open product as well as the dataset and the variable here and here. So these two layers come from two global forecast projects. The first for the physical data, here the temperature, and the second for biological data, here for the chlorophyll A. In this presentation, we will focus on the Agulhas current, this strong current south of South Africa. And we will see how the temperature of the waters follows the intensity and the direction of the currents. So to search for products through our catalog, you just have to click on Add Layer here, and you arrived on the Copernicus Marine Data Store, where near 300 products are present. So we therefore have all our products classified different categories, the most popular, and you can also click in the arrow to see the rest of the product in this category. You also have the recently view for the projects recently opened on your MyOcean, the indicators and trends, and so on. The short description of the products informs us about the name of the product here, the data simulation mode, whether it's a model or an observation, like here with satellite. You have also the temporal coverage here and the variables present in it. The filters column on your left allows you to refine your search by entering keywords or informing the time coverage, or clicking directly on the parameters corresponding to your search. So I can write here current, for example, or even mark velocity as a variable. I will add the global OSHER for the area, and I will choose the hourly for temporal resolution. And I want to stay on the numerical model here. So you have here 4 projects correspond to your search. If you look a little closer at the name of this project, you can see that the first it's a forecast project containing a physical variable such as mixed layer thickness, salinity, sea ice, including current speed, the velocity here. It's therefore a project containing the most recent data because it's analysis and forecast. Then we have multi-year projects relating to older data and having wave data, so it's not interesting for us here. The 2 last projects are multi-observation project containing model data and satellite observation. And in your case, we will stay on the most recent data and thus select the global analysis and forecast project here. So we arrived on the description page of this project, where you can find a short description of this project and the references when available, and a section called classification here describes the parameters taken into account in this project, like the spatial extent and resolution, the variable, and much more. On the left, you will see other tabs like notification that tracks all the incidents, improvements, and maintenance in progress or past in the project. The data access tab, which allows you to access different data sets contained in the project, as well as direct links to the Motu interface, OpenDAP, FTP, WMS. By clicking on the small bubble here, information icon, you can arrive directly on the articles of our Help Center by linking with the chosen access mode. This article are there to explain you how to use the download mode, how the download mode works. The contact tab here allows you to contact the Help Center, and then you have a documentation section with links to the user manual document, the quality information document, the license, and a link to our article how to cite Siemens products in your work. The user manual document contains all the information relating to the project, and the quality information documents provides information relating to the mode of data acquisition. If you like the project, you can share it using the share icon here at the top right, and this button allows you to copy the URL address of the project. So to visualize the variables of the project, you just have to click on the Add to Map, and you can then choose the variables of interest in the different datasets of the project. You will notice here that each dataset concerns a type of variable with a different temporal resolution of the data. The 3 first are data relating to the current here, every 6 hours for 6H, daily with the D, and monthly. Then you have the salinity here and the temperature here. All this dataset contains variables in 3 dimensions, and the rest, so the analysis and forecast here, and the merge UV, it's 2-dimensional data gathering many variables. So I will choose the 3-dimension dataset in order to explore the most features of the MyOcean viewer. So let's take the first dataset and choose the seawater velocity variable here. And I click to Add to Map. Okay, so you have here our 3 variables open on your interface. You can easily pan around the map by holding down the left click and zoom in and out using your mouse wheel. For more visibility, we can change the priority order of the layer by dragging them up or down. Here, I can also choose to hide a layer or not by using the eye here. So you can also delete a layer by clicking on the cross, and here we will remove the data layer from profile A here. So you see that 4 to 5 icons are present. The first is the download icon here. The second return the project description page. The layer icon here allows you to change the open variable by another present in the product. The gear is used to customize the layers, and finally the log icon is used to apply a logarithmic scale to the data. This option is not present in all the variables. For the sake of the visibility, I will modify the opacity of the current layer, and I will change the color palette here. I can also modify the minimum and maximum values to apply and decide or not to mask the values exceeding the limit. Here we have another option, a variable, the style. It's a unique feature of a velocity layer. I can make this layer as a solid, like here, solid plus vector, or only a vector, and I will choose to simple visualize the vectors. So regarding the temperature layer here, we notice that the information icon that it's the same product as that we previously opened. With this layer icon here, I can view another dataset like the temperature variable, but for the resolution of 6 hours here. I will also change the color of the temperature layer by clearly see the difference here. Okay, it's better. Thanks to the bottom bar here, you can change the date of your visualization. A variable data is symbolized by the thicker white line here. And if I choose to visualize the several dates randomly, like this, we notice that the Agulhas current is one of the most regular that we know. By zooming a little more, by scrolling with your mouse wheel, you can even view the data hour by hour here. This is only possible because the data is hourly data. And if you use the left and right arrow on your keyboard, you can also change the date of the data visualization, but 6 hour by 6 hour. Another option is available with the 3-dimension layer. You can select the depth level thanks to the bar at the right. By default, the data displays the surface data here, but you can change this parameter by clicking on the scale and use your up and down arrow on your keyboard. You can also zoom in and out using your mouse wheel on the bar. And we can see that the egress current is the surface current, which dissipates with the depth. Above this scale, you have different objects that can be created, a point here, lines for transect, and area here. You have also the settings of the MyOcean viewer, where you can, for example, change the units of your object, like here, the units kilometer or miles, and the units of your area. The creation object is useful for visualizing graphs based on your open variables, but also for downloading this particular area. And for more visibility, I will delete some object here. Yes. So you can see here graphics appear with the creation of object. This is a representation of the sample of data for this location. You can delete graph here and make other appear depending on the variable open on your HFS. Here for temperature or sea weather velocity, you can add graph. You can also choose to download this data in CSV format here. But to do so, you must enter your credential, Siemens credential. Here it's worked because I filled it before. If I log out using the settings here, you will see that clicking on the icon for downloading the sample in CSV format is reserved for users with an icon and the user that's registered. As a reminder, the registration is completely free. Your credential will be requested if you don't have filled it before. Each time you want to download the data. Thanks if I click on the download icon here, I must connect. So not that the downloading of the data is only carry out a sample of data. It doesn't reflect all the data in your object, even if you increase the resolution like this. So let's move on the download part. To do this, let's go to the download icon of the variable you want to download. Here, we need to fill in the geographical area we need. We can either manually enter your coordinates or use the define on map option. With this option, you can draw directly on your map your area. Here, you can also the coordinates are enter. You can also delete your area using the cross here, and you can even select a previous object like this, for example, for the point. The date range section here, you must fill the time period you are interested in. Next to it, it indicates the time period available for this variable in the product. To be sure to indicate dates including in this one. Same way as the define on map option, you can automatically select the date on your visualization by clicking on as in map here. And if I dezoom, I can select another date here and as it map. Same things for elevation range. Here I will stay on the surface data here. So for datasets containing several variables, you have an additional section called also download, which allows you to download several variables containing in the dataset at the same times. For example, I will change the temperature layer with a dataset with many other variables here. And if I go to the download icon, I have the option also download, and I can select the other variable I want to download at the same times at the CI surface. Okay. So I will delete it. Okay. A word of caution though, downloading via Motu is subject to 1 GB data download limit. If your request exceed this limit, like this, for example, like this. Okay. For example, here, a red message appear in red, and the links takes you to the data access tab, from where by clicking on the information icon, you have access to article from our Help Center as seen previously. Next to it, you have the Show API Request button, which allows you to obtain the requests that correspond to your parameterized data. This request is useful when you want to download your data programmatically, for example. In case of problem, you can contact the Help Center by clicking on the small bubble at the top, talk to an expert here. If you have a problem, in particular in the download problem, it's important to communicate to us your API request that we can help you as best as we can. To do this, I will open a chat section and click on the API request, copy and paste it into my message. So you will also notice that in the home tab of this chat, you have directly access to our article here present in the Help Center. You can search for an article by entering keywords such as MyOcean, for example, here. So you have, by the way, an article that tells you how to view the data in the MyOcean Pro, like in this presentation. You will notice that at the end of this article, you have a question and answer session that we regularly update with the most asked question about the MyOcean viewer. So the MyOcean Pro has also a sharing functionality by clicking on the icon here, share. You can then share the link of your visualization with whoever you want, create an image or even a video. You can even generate an embed link to include your visualization on your website, for example. So finally, you have an information icon here, which details all the keyboard shortcuts you can use on the MyOcean. Don't forget that we have some articles available on your Help Center concerning the MyOcean viewer, but not only. the user support team is nevertheless here to answer your question and to help you if you encounter difficulties. Thank you.
Thank you, Anaïs. That was very cool. I always like your presentations. Just a quick reminder to everyone. I know this can be a bit overwhelming if you're seeing this for the first time, the viewer and all the tutorials we will be showing you to you today. So we recommend you not to try to follow it at the same time. Just sit down and relax, try to understand a little bit, and then you can later on maybe rewatch these presentations and do it at your own pace, especially if you're a beginner. We don't really recommend you to do that. So now if you can stop sharing your screen, Anaïs, I will share the, thank you, the questions. And we already have a few questions for you. And where are you here? So, first question. It always takes a little bit of time. Oh, yes. Oh, okay. If you use the MyOcean system to create a figure for publication, would it be sufficient to cite the dataset used, or should you reference MyOcean as well? I don't know if you're aware of this, but yeah.
I think you just have to cite the reference of the product you use in your in your works, like credits. That's
yeah. No need to for extra. Oh, yeah.
We have an article on your Help Center how to cite Siemens products in your Help Center that can help for this question.
Okay, yeah, great. I will put it on the comments then. Great. And can we get access to this video? Oh, I think you mean the presentation of today. If you do mean that, yes, everything will be available on the Padlet that I mentioned in the beginning of our workshop. So you will be able to rewatch all of this. Can you scale the vectors on the velocity plot?
The vector is automatically applied and calculate. I don't think it's possible to change the direction and the length of the vector, but it can be an improvement in the future.
Yeah, for sure. Is it possible to add other colors or like to the color bar, such as on the color map?
For the moment, we have a palette of the color, and you can just select the color present in the Help Center in the MyOcean.
There's quite a wide range of colors already as well. I find it. You just have to find which one is the best. Is it possible to download in PDF format instead of CSV format?
No.
Only CSV, right? Yeah. What is the format of the data when we download it, and what software can we use it to visualize the data? So I guess CSV.
Format.
Oh, or the data, they are visualizing it on the viewer, maybe.
You can use embed link in your HTML website, for example. You can also use the embed link in your notebook in Python, for example. It's just for visualization. You can, if you want to download your representation, your visualization, you can use the share video or image in a PNG format.
Yeah. Okay.
And when you download your data, it's a NetCDF format.
And one last one, maybe. Is there any information about the differences between data sets? How do we know which one we have to choose?
Yeah, you can refer to the user manual document or the quality information document. In this document, you are also technical information about the product. In the quality information document, you have access to data access mode, data acquisition mode use, and you can, thanks to this document, shows the products that must fill in your needs.
Great. So plenty of information. You just have to look for it. Great. Thank you very much, Anaïs. Unfortunately, we don't have time for more questions, but we will try to answer them all, ask our speakers to answer them later on and share with you the answers. Thank you very much, Anaïs.
Thank you.
Bye. And now I will introduce you to our next speaker, who's gonna present us a very interesting tutorial using a Jupyter notebook. Alvaro is gonna be with us for the next hour or so.
Hi, good morning.
Good morning. So yeah, whenever you want, Alvaro, the floor is yours. So just a quick reminder to everyone, this can be a bit overwhelming, so try not to do it at the same time. And don't worry, you will be able to do it at your own pace later on. Okay. Okay,
Yeah.
enjoy.
It's interesting to think that, well, despite of these tutorials are designed for people that doesn't need to have previous knowledge, but if you want to have 100% of understanding of what is in the tutorial, maybe it's quite overwhelming and you need deep knowledge. But even if you don't have many knowledge about the Python environment, you can run the tutorials, you can run the examples, and you can learn a lot, I think. So this is, as always, is just start doing things, and in this path you learn a lot. Let me share my screen. Is this one? Is it? It's okay? Can you?
Yes, perfect.
Okay, great. So I'm gonna jump here. Probably, yes, Frederick explained how to reach to this web page where you can log into the Jupyter Hub. This log is done with your username and your password from Copernicus. And when you log here, you get this. You get this web page. So here we can have, or you can see, there is two specific areas. This is the area where we are gonna work. There is, in the left side, there is an area which is a file browser. You can see here there is your folder. This is your home folder. For me, it's the home folder for my user account, and I have few folders inside of the folder, but any user can have their own folders here and their own documents. Just you can make a right click here and create folders, create documents, etc. We will see later how does it work. And also we have here the bigger workspace. This is a workspace where we are going to spend most of time. And you can see this works in a viewer, in a web viewer. So well, you can enter here with any viewer, and for sure you can collapse the file browser just clicking on here. it's interesting here. We have some elements. The notebooks is the main element we are going to use here in this tutorial, and we also have the terminal. These terminals are terminals of Linux systems. So if you click on here, you can enter in a terminal of the Linux system here in your home folder. I don't know if the people knows much about Linux system. Just it's a system where you can work with commands. For example, if you write """, you get the list of directories, the list of folders you have in the directory where you are. So you can also move from one directory to another with CD. You can write CD to, for example, this old. So now I am in the old directory. So I can see different courses and different files I have stored here. To go back, you just can write cd space ... and you come back to your home folder. Well, this is a tool we are going to use to copy the training, the tutorial to our home folder, because it's really important for any user to keep in mind that first of all, we have to do to start working is to copy the tutorial, copy the tutorial to your home folder. If you don't have the tutorial copied here in your home folder, you won't be able to run the tutorial. You won't be able to include changes in the tutorial. And one question is, where is the tutorial? Well, everyone should have this link, share notebooks in their home directory. So following this directory, we can, let's expand this. We can see a lot of trainings that has been created in the past. So any user can go for these tutorials and these trainings, and probably most of them are shown in the web page of the training. So anyone can take any training and start working and learn as much as they can. In this case, we are going to focus our attention in this training, the training for Africa to 2023. So to copy this training to our home directory, the first thing we are going to do is this one. With right click, we have here the copy path. We can copy the path of the tutorial. We copy the path, and now in the command line we can write copy -r. It's important, this -r, and we can paste the path we have copied here. You can see it's very simple path, which is shared notebooks, training Africa 2023. Actually, is this path, shared notebooks, training Africa 2023. And after this, we have to write where do we want to copy the tutorial. And so we can put just a dot. It's important to put this dot. If we don't put this little dot, this becomes in an error. These are the rules of Linux. If you don't put things in this place, in its place, you will get lots of errors. So we can put the dot. And well, this can take about 30 seconds, about 1 minute, not much. I think it won't be so much. So we come back here. Clicking in this folder, we come back to the home directory, and you can see it has finished. You can see here we can continue. It's writing our commands. So this means that the system is finishing copying tutorial, and here we have now the new folder of the training for Africa. So now we can start working in the training. Just now, not before, because now we can include changes in this folder, because this folder has been copied into our home directory, and we are the rights to modify the folder, right? So we can close this tab right here. Let's go over the training to see what it has. Well, it has just 3 new folders. A folder with what that we have called data. These are the folder with the data downloaded from KMEMS. I will talk about this later. We have another folder, figures, which is empty right now, and images that is not very interesting. This folder includes images for notebooks. And here we have what is really important for users, for any user, the first and the second notebook for beginner, for users, and for intermediate users. Now we are going to work with this beginner tutorial. So let's open it by double click on it. Well, we have it right here. I don't know why this, I'm sorry. Image is not working. Ah, okay, sorry. Well, this is the beginning of our oh, I'm going to collapse this. I think it's clear. Well, this is our notebook. What is a notebook? Well, a notebook is kind of a book where we have included a lot of information, some images and text explaining a lot of things. And from time to time, we will find this kind of cells. These cells are wrote in Python language. Python is a programming language, a high-level programming language, very famous. So these cells, you can run these cells by, as you can see here, by clicking this play button here. So you can click here, and here is running the cell. And now when you see a number in this little box, the cell has finished. You can see it has some time to run. That appears an asterisk, but it's very fast. But well, this is so all the tutorial, as you will see, is all the same: text and cells, text and cells. So we'll go over this, not very fast, and you will see how it works. Well, as anyone knows, we are in a tutorial about Africa. So for this tutorial, we have selected just a specific region of Africa, which is the system of Angola-Benguela Current. We think is a very interesting oceanographic system with lots of features, as the Benguela Current. It's located, this area is located in, as you probably know, in the southwest coast of Africa, and it's affected by the Benguela Current, which is the closure of the subtropical gyre in the South Pacific, South Atlantic, I'm sorry. And we also have 2 important currents: the Agulhas current that comes from the other side of the continent, a very strong current of western coast, of western margin, ocean western margin. And we also have the current, the South Equatorial current, that brings very warm, high temperature water to this Angola region. And here in the Namibia and South Africa coast, we have a parallel current to the coast and a parallel wind to the coast. So as usually happens in these cases, we have a very quite big, one of the biggest whaling regions in the world, one of the 4th biggest whaling regions. And this also, this situation, or the combination of these currents, these different water masses, creates 2 frontal regions: the Angola-Benguela front and the front of the Agulhas current, right? Well, we are going to spend some time in this case, in this beginning tutorial. We are not focusing so much in the description of this region. We are going to focus our attention on how to get the data and how to open the data, the Copernicus marine data, to have a first view of these features. Well, we can continue. Here we have a cell, a code cell. As I said, well, we already ran this cell. We can run again this cell. Yeah, probably the people who knows about Python will know that first thing you have to do in Python is defining what kind of libraries are you using, because Python is quite like a calculator. For example, let's make an example. Very simple. For example, we can create here a cell. Python is like a calculator, simple calculator. For example, you can write 2 plus 3, and you can run this cell, and obviously the response is 5. It's quite simple, but you can also create variables, right? Like, for example, number equals to 5. So or equals to 6. If you run this cell, you will realize, well, this doesn't, and you print number, you will see that, well, you get a 6, what is quite obvious, but you can also say, what if I put number plus 2? I can run this, and I get an 8, obviously. Number is 6, and I add 2 to the number, so I get an 8. Well, this is a very simple example, but if you want to go deeper with doing more complex things with Python, you always need to, I can delete this cell. You always need to get libraries. Libraries is what in Python allows you to do complex things, because Python in the first layer of Python is quite simple. You have possibilities of do many things, but you cannot do so much things. So when you want to do complex things, you need to import libraries. Here, usually in Python, we write what libraries are you going to use in the first lines of your program. So here we have the list of libraries we are using. The first library is just to avoid the warning messages, so we will forget it. And we are using a library called NumPy, XRI, Matplotlib, and Cartopy. Well, here you have the links to the documentation of any library. For example, you can click here and you go directly to the library and to the documentation of the library, so you can get all the information, the deep information of each library. But I will tell you as very short information. NumPy is a library devoted for scientific computation. I'm sorry. Devoted for scientific computation. So this library is giving you options to use complex mathematical functions like the logarithms, the square root, and also you can use arrays, multidimensional arrays, etc. We are going to use also XRI, which is a library very related with NumPy, and we are going to use this library to open and manage the netcdf book and the netcdf files that are downloaded from Copernicus. And we are going to use Matplotlib and Cartopy Matplotlib is a library for plotting for any kind of plots. You can plot whatever you want, from a scatter plot, an histogram, or any kind of mathematical plot, scientific plot. And also Cartopy is an extension of Matplotlib library that is devoted to make plots projected over maps. So you will need some kind of geographical projection like Mercator or any other. So Cartopy is the library that allows you to these kind of works. As you can see, we are importing the library, and after the importing, we are using a surname, XMP, XR, MPL. So from now on, this is the name we are using to refer these libraries. So now on, when we write something like np dot wherever, we are referencing to a function that is included in this library, right? Well, after that, let's go. We have setting up the Python environment, and what we need now is some data to start working, right? So there is many ways. For example, Anaïs previously explained how to download data from Copernicus, and I think there was a question in the chat asking about how can I visualize the data once they are downloaded. So well, we are in that part. We are now, there is, for example, in this example, we are going to focus on this Copernicus product, global analysis and forecast, physical. And this is the web page of the product, and you can see we have the window to explore the product in MyOcean. Here you have the links, very important links of the user manual and the quality information document. These are the links for the high-level information of any product. There, these links in this document, you will get the very specific information of any product, how is it created, what kind of products are used, kind of models, observations, etc. And here you have a summary of the information of the data you can download from this product. For example, the ID, very important, is a numerical model, the spatial coverage, that is the world, spatial resolution. This is quite interesting for models because, as you probably know, the models has a specific mesh. So this is the resolution of the grid. The temporal coverage, the temporal resolution levels, and the variables you can access with this product. This is very interesting because here you can find the variables, or you can know if this product fits into your interest or into your requirements, right? So with these buttons, you can select the data you need, etc., and you can select the temporal extension you need, the depth, the window you want, or the product. And I explain it is this code. You can see here hourly data, daily data, monthly data for currents, for salinity, for temperature, etc. Well, we are not going to spend much time in this now because we are assuming that you can download this data, and we have here in the Jupyter Hub, in your tutorial, you have the folder data where we have some files, some example files that you can use, that we can use for this example. So download it from using this web page. So we encourage any user with this information, he can try to download these files, download this product with this data set. As you can see, we are downloading daily data sets for this window, for this in latitude and longitude, for this depth, and also we are using just one level of depth. And well, we have we'll see later, we have downloaded a month of data, but any user can download a period of time that he likes, for example, for a few days, a week, 2 weeks, and he can follow this exercise without any problem. And well, here we have another code cell. You can see here what we have is two strings of characters that are assigned to a variable, temp fname and cur fname. This is just an association of the path of any of the data we are going to use in this example, and we are associating these names to these variables. So from now on, for example, we can run this cell, because as you can see, this cell is not run yet. Okay, and if we create a new cell here, if we print temp name, and we run this cell, oh, sorry. We get the name of the file and the path of the file we have under this variable, right? It's simple. Well, so we are going to continue. We have our data, we have the setup of Python. We can start work right now, okay? So the first we have to do is opening our one dataset, for example. To do that, we use, as I said before, we use the library XRI. It's a library that as I said before, we are contracting to XR. So we are using XR dot a function, the XRI, that is open that dataset. You can see here this sentence. When we are after opening that dataset, what the dataset do we have to open? So after that, we have to include the name of the file we want to open. This is the file name, the temperature file name. And well, this sentence just writes, let's run and we will see what do that sentence. Click on it, and you can see when we put this sentence, what we receive from this is a little report of the information stored in this dataset. As you can see, the result of this sentence has been assigned to this variable. So now we can access the information of this file, accessing this through this variable. We can refer to this variable to get the data in this file, right? Well, when we print this variable, we get this, and well, I don't know how much knowledge about the netctf format you have. So I'm going to explain a little bit about the netctf. The netctf files are a type of files very used for storing geophysical information in a funny type for methodology, for oceanography. And this kind of files has three types of objects, let's say, three types of elements, which are variables, dimension, and attributes. For example, we can start explaining, for example, you can see here in the report, we have attributes, dimensions, and despite of here, we have coordinates and data variables. These two elements are actually variables, are the same, but they have little differences, but they are variables. Let's start with the attributes. These are the global attributes that affects the file. So here, if you open these attributes, you can see some information about the file. Sometimes there is not much important information in here, but maybe you can get the information of what kind of product are you downloading or are you working, of where it has been downloaded, etc. And here we have the dimensions, which are just the name of the variables that will be used as dimensions. Well, these dimensions you probably will see that are replicated in coordinates. As I said before, coordinates are kind of variables. The variables in an etcdf file are the elements that really stores the data. They are not devoted to describe the data. They are devoted to store the data. So when you want to access the data, you have to access the coordinates or the variables itself. And here we can see that coordinates are one-dimensional variables that stores the values of the different dimensions. You can see here we have a file with 32 depth levels, 300 latitude values, 34 values of time, elements of time, and 241 elements of longitude. So, well, if we click here, we can get a report, a short report. These are called the attributes of this variable. These attributes are really interesting so many times because you can get the minimum value of the variable, the maximum value of the variable. As you can see here, we are talking about the dimension depth. So in depth, we have values that goes from 0.5, let's say, up to 500 meters, more than 500 meters. It's expressed in meters, and well, this is the information, and you can click here. You can have some information of the specific values. In this case, you can see the values specific. And well, for example, we can go over the report of the time to see the attributes. Well, it's maybe this time we have the minimum and the value, but in real, in the file, these values are ours since this date. So we can go over the data directly to see that in this file we have data from from April 2023 up to 4th of May 2023, right? And well, once we have seen the variables, the coordinates, which are one-dimensional variable, we can go over the real data. You can see here in the variables are not one-dimensional variables. They are, in this case, it has 4 dimensions. So here we have set out, let's go over the report to see this variable stores values of temperature for these 4 dimensions. And well, here we can see that first dimension is time, depth, latitude, longitude. So these dimensions are these dimensions. So we have here values of temperature for this block of the ocean for this period we have defined it, right? So how can we access this data through using the Python? Well, I wrote here some examples. For example, maybe this is clearer. When you can access, for example, a variable, like for example the dimension, you can write the temperature, yes, as you can see, when we have opened the file, we created this variable, the temperature, and this is our handle for the data inside of this file name, right? So to access a variable, we can write temperature ds, and we can include the name of the variable between brackets in here. So with this command, we are accessing the variable time in the file. as you can see here. As you can see here, every variable and every dimension has its own name, depth, latitude, time, and longitude, and theta. So this is the name we use to access this specific array of data, right? So we write this command, we will get a display of this specific. I'm gonna comment this just a second. When we run this, we are getting a display of this variable inside the file. Well, we have the report of the time variable inside the file. For example, let's uncomment this. I didn't talk about this, or any line that starts with this symbol is a comment. So the system doesn't take it into account as an order or a comment. So you can comment any lines and see what is doing that line, or you can remove lines without removing them. So here we have another way to access the data. What if we want to access a list of attributes of one variable? What we can do is, for example, here we have the name of the dataset, the dataset, the name of the variable, and after that we can write a dot attributes, right? So if we run this, with this we are getting the list of attributes of this variable latitude, right? Valid mean, valid max, etc. Let's comment this again. Let's uncomment this. And well, this example is actually two examples together, this one and this one. And what if I want to print a specific attribute? I've seen that there is many attributes here for any variable, but what if I want to print, for example, just the valid max? Well, so for global attributes, we can access the file with its name, with its handle. And well, since we are not accessing any variable, a specific variable, we can skip the definition of the variable, and after that we can put attributes with the name of the attribute we want to print. Or for the case of variables attributes, we do almost the same, but we have to define the name of the variable we want to print, right? So if I run this, well, we can get for the global attribute of temperature, yes, of title this is the title, you can see. And here, for example, if we want to access what are the units of temperature in the file, well, we can write this now, and we will get this information, right? So with this, we are able to access the data, and we are able to navigate through the data. But well, now we have some knowledge and we are some power over the data. It's time to start plotting things, right? Which are actually the most interesting thing, probably. Well, let's start with an example of how to plot maps of temperature. For example, first thing you will see in this tutorial that we are going to do for any kind of plots, we are going to use two steps. Let's say they are two steps. The first step is a step where we are selecting the specific data we want to use. And the second step is a step where we are plotting the map or the figure, right? So why do we do this? Let's imagine we have here, we have a file with a 4-dimensional array, how can we plot a map from a 4-dimensional array? Well, we cannot plot maps of 4-dimensional data, right? We have to select just a slice of data that includes latitude and longitude data. So to do that, we will need to select a specific depth, and we will need also to select a specific period, a specific date, right? So this is what we are doing here. You can see here we are assigning the value of the date we want to plot and the depth we want to plot, and we are using a function, a function called cell that is included in XArray. So when we access the data file and the variable in the data file, and we write cell, we can select specific values inside the variable. So here we are defining that we just want the depth equals to depth, which is 0, and we want the period of time that is equal to date, which is this date. And well, we are using the method nearest. That means that we are looking for the closest period to these requirements. With this variable, just removes the collapses the dimensions with just one value. We will see this later. We can run this cell, and well, we have again we assign this selection of data to a new variable that I've called temperature to map. This is the temperature we want to plot, right? So this is the variable we want to plot. As you can see here, right now we just have 2 dimensions, latitude and longitude, so we can plot up with 2 dimensions, right? And these are the data of temperature, and here we still have the coordinates, the dimensions, the coordinates, etc., as in the main file. But here the important is that we have this slice, this style of data and we can use this data for plot a map. Well, if we remove this, just to understand what is doing this squeeze, if we remove this and run again the code, you can see that we will get a 3-dimensional array, but one of the values of the dimension is equals to 1. So when we use this squeeze option, I will run it. What a squeeze does is to remove all dimensions with size equal to 1, right? Well, it's better later when we go over the functions of plotting to have to work with arrays with just 2 dimensions, not 3. Well, after this, we go over the block where we are plotting our map. This, well, could be quite complex for people who is not very related with Python, but I would say that we can think on this as objects. It's quite simple. What we are doing here with these commands is there is four sections in this cell. First, we are creating the figure in the world of informatics. We are creating an object that is a figure with some. This is the figure, and as usually from now on, we will refer to this figure with this name. We are creating an axis into the figure, and since this axis are axes that will be plotted in a map, we need to define a projection. Oops, I'm sorry. we have to define the geographical projection we are using. After this, we have a block that is editing the edition of the basic features of the map. And after that, we will go with some commands to plot the data. And finally, we will finish the edition of the figure, right? Well, in this second, we have already explained this first block. Once we have the figure and the axis in the figure, we can start to modify the figure and the axis. So with these commands, we are including some features in the axis and in the figure. For example, with this command, what we are doing is add coastlines in the figure, and with this, for example, this is interesting, the land feature. With this, we are including a land mask. Maybe it's better if we continue, and after that, we can run the plot, and we will see what are doing these lines. And here is probably the most important command, which is the command that uses the function pcolorMesh, that creates pcolorMesh. You can follow the documentation of pcolorMesh. Is a function, a matplotlib function that creates a pseudo-color plot. With this, you can create a pseudo-color plot. You get every pixel. So to every value of the pixel, you are seeing a specific color. And when you use a function in Python, you just have to give to the function the specific values in this order that the function needs. For this case, we have to assign to the function this the data of latitude. You can see temp to data. We said before that temp to data is the data we are going to plot. We are accessing the specific values of longitude in the temp to data to map, and with this we are accessing the specific values of latitude in our array, and with this we are accessing the values of temperature, the specific values, right? And what this I will explain later which is this. This is the type of color map. And finally, in the last block, we have also some editing commands, like including some title in the figure, and also including the color map, the specific color bar. So let's run this and let's see what do we get. Well, here it is, our first map in Python. Well, you can see here, I included this map, very big map, because I wanted just to include, you can see in this map, we can see almost half of the continent. And this region is the region where we have data, right? I did this in this way because I wanted to give some framework information for people. Maybe there is people that is listening, not very related with the region we are working on. So I just wanted to plot this map this way to see what region in the world we are right now working, right? Well, this is our working area. This is the area where we have data, and this is the rest of the Africa. But probably if we are working with data, we don't want to plot the half of the continent, right? So this is because I've included this command line here in the editing, but editing of the features of the map. You can see there is defined the extent of the map, including the minimum and maximum longitude and the minimum and maximum latitude. We can just remove this line. So if we run again this cell, well, we get a map that is adjusted to the extension we are plotting, we are interested in, right? It's much better. So, but it's interesting to see that this, what is the purpose of this kind of lines? Is this kind of things? For example, you are defining, for example, the extension of the map, or you are including the borders of the countries. For example, I encourage any user, he can play with this. For example, if you can know what, if you want to know what is this line doing, you can just include the line as a comment and run again the thought. And what happened here? What, as you can see, the difference is that you probably we don't have a field. We haven't filled the continent, so we have a white continent. For example, we're going to run again, or for example, you want to know what would we do in this line? Let's imagine. Well, we can run again. We can comment this line and run again. And as you can see here, the result of removing this line is that our color bar has disappeared, right? Here, after the plotting of the map, I've included some exercises for the users. It's just to have to promote some thinking about what we are doing and we are seeing. The most important of plotting maps is not just plotting maps. It's first see what is in the map, right? So let's see what's actually is in this map. You can see here the signal of cool water close to the coast of Namibia, to the coast of South Africa. This is the signal of the upwelling region of this region. And here in temperature, we also have a river, a clear river of temperature that is related with the current of Agulhas current. And we also have some views of the importance of the water of the dome of Angola. So you can see there is very hot water in this region, so there is a frontal region right here, and also a frontal region that appears in this line. Well, coming back to the exercises, yeah, I propose to the user, you can try to do it, and I think they are not very difficult, so I encourage anyone to do it. Just try to modify the code, modify the long limits of the plot to create a map focus in a specific region. Well, this is something that we have already explained because you have this line, so you have to uncomment this line and use these parameters to focus your attention in any place of the map you think you could be interesting. Well, we can how another exercise, another proposed exercise is let's change the plotting depth. How would you explain this appearance of data with depth? Well, how would you change right now we are plotting, as you can see here. We are plotting the depth equals to 0, but let's imagine we want to plot, for example, 200 meters depth. Can run. Always we have to be careful because our main file has data from surface to 500 meters. If we ask for a deeper layer, we won't get information about beyond that limit, for example. So we can change the depth to 200 meters. And we can run this. And this is an interesting result, probably. We are asking for data at 200 meters, but if we go here to see the real depth of our data is 186 meters. Why is this happening? Well, because probably if we go here to the main file, let's see the depth variable. This is quite difficult to see here, but here is the value of 186 meters, and the next value of depth is 222, right? So since we are using here the nearest method, the system is looking for the value of depth closer to this requested value. So it finds that the value of 186 is closer than the other one. So for that reason, we are getting this information. This has a little bit dangerous because it's quite nice. You won't get any error with this nearest method, but let's imagine we are looking for a value of depth. This is too much, but let's imagine we ask for a value of depth of 2000 meters and we run the solve. Well, there is no error at all, so it works fine. But despite you probably are thinking that you are working with that data of 2000 meters depth, you actually are working with data at 500 meters, because this is the closer value in your data set, right? So let's imagine we want to use 200 meters, and once we have defined it and we have selected our data to 200 meters, we can run again our code here, and this is what we get. This is the values of temperature at 200 meters, right? You can see here there is a question that something that rises is that there is a lot of values here that doesn't appear, are missing, and well, why are they missing? This is clearly because we are in a deeper layer, so the coastline doesn't apply in this depth. So the bathymetry is more like this than the coastline at 0 meters depth, right? And finally, I propose to modify the color scale of the map using other color scales from this documentation. Here you can see the color scales. There are lots of different color scales. You can select any color scales you want for your plots. We are using this one yet, which is quite common to use this. But well, we could use, for example, another one like let's imagine we want to use this. Since we are using temperature, we could use this one. So we can use hot color scale. So we can change here and CMAP instead of putting CMAP. We can write hot. All right. Again, the solve. So you get this. Is quite alarming map, but well, this is the color scale we have selected, and then there is something that maybe seems to be wrong here. Let's go back to 0 meters depth and run and rerun this again. We come back to surface, and looking to this map, we could find that there is something wrong. That, well, we said that our temperature was cooler here, but right, the color seems to be more associated to very high temperatures, right? actually the color scale is reversed. And well, there is a little tip about the color scales in this kind of color scales. In any color scales you use, you can include an underscore R. So with this R, you are reversing your color scale. And well, with this, we have the color scale in the direction we are interested in, right? Well, this is, well, finally we have our map. We know how to change some things in maps. So I encourage to any user to change things here to see what is the result in the map. And we can go a little bit beyond because we are plotting scalar values, but what if we want to plot a vectorial value? For example, the currents would be very interesting. How could we do with currents? Well, let's see. Let's start a new example. For this example, we are opening a new data set. You can see we are using this function that we already explained before, but we are opening the file associated to the currents, right? And we are creating a new variable that is current data set, right? So we can run this. And again, we get the report of the data we have. And as you can see here, we have a report that is almost the same than before. We have dimensions, attributes, and variables. In coordinates, we have one-dimensional variables, which are actually the dimensions. And in variables, we have two variables. We don't have one variable than like before. We have two variables. And if we explore these variables, we realize that there is VO, which is a V component of the velocity, of the current velocity. This component is oriented in the north-south axis. And where is the other one? The other one, the UO variable, is the U component of the velocity that is oriented in the direction of east-west, right? Both of them are measured in these units, meters per second. And well, we will have to work with two variables, not one like before. And something that arises here is that, oh, well, these are the dimensions of that data set. We have one value of depth. Oops, this is different than before. We have almost the same latitude, time, and longitude values, but we just have one value of depth. So that data set doesn't include information in deeper layers. It just includes information in surface. Well, this is just because we have decided to select when we are downloading the data. We have decided, well, we can save some space in our computer, so we can just select the layer we want to use, and we will get lighter files here, right? So once we have opened we are going to do almost the same than before. So we are opening the file, the data set we are using, the data set we are using. After that, we are selecting the data we want to use. And after that, we are defining the block of code we are going to use. It's almost the same than before. It's very simple. We already have our data set open. So from here, we can select the data, obviously, since we are working now with two values of two variables. We have to select, we have to write two orders to open both variables, to select both variables. And as before, we are using the self function, selecting the time we want to use. But as you can see here, in comparison with what we did before, there is not selection of depth in here. And what is this? Why is this? This is because, just as I told before, we are using a file with just one depth, so we don't need to define a specific depth, because the depth is the depth is the depth that we have in the file, right? So we don't need to specify any depth here, because there is just one value. And well, we can run this. Well, I am just print here that one of the variables, the v component, and well, we get this. Which is important is we have a variable with 2 dimensions, which is very important to plot a map, because we cannot plot maps with more dimensions. And these are the coordinates. The depth value is about half a meter, latitude, time, and longitude. The time is the time we have selected, May the 4th. And well, this is the component v, but we could also print the component u. And we jump into the next cell, the cell where we are plotting the map. These cells are always a little bit more complicated. That science here we are also using something that is very convenient in programming language. We are using a function. We are creating our own function to plot things. What is this function? Well, since we write this line up to, we write this return, everything is tabbed here. So this code is stored in this function. So this function is a way to pack a list of commands inside just one command, one order. So we are defining a function. You can see here the name of the function is plot magnitude map. So from now on, since we have already loaded our function in the memory of the system, we will be able to plot maps just using this function. We will write plot magnitude maps with the specific parameters we have to use, the component u, the component v, and the title of the plot. And the function will do the rest of the things. So with this, we are able to pack the information, the code inside a function. This function is almost the same that we have done before with temperature. You can see there is a first block for the creation of the figure, a second block for the addition of the figure, a block for plotting, and a final block for the final edition that includes the color bar and the title, etc. But this function has just one difference with the code we saw before in the case of temperature, which is this line. This line is, since we are working with components, we cannot plot the magnitude of current speed, because we need the magnitude of the current speed, and right now we have to transform the components into the magnitude. So that is what we are doing with this. We are using the root square of the function of root square from NumPy to compute the root square of u times 2, etc. This is a bit clearer. With this formula, we are computing the magnitude, and we are not plotting the components. We have to plot the speed, right? So we use the longitude of the speed, the latitude of the speed, etc. Right? We use this color map. As you will see, it's not the like the previous one, but at the end, this still takes some time. Well, we get this, we get a map of the current speed in meters per second. You can see here we have a map of the Agulhas current, where the Agulhas current is really, really clear. And also we have an interesting current here, but this is not actually what we wanted from the beginning. In the beginning, we wanted a map of vectors, not a map of an scalar. This is not a vector, right? So let's imagine how can we change this function. We have defined this function, which is nice to plot the speed. Let's imagine how can we change this function to include in this map also the vectors, right? So this is what we have doing in this cell. As you can see here, again, we define a new function, which is plot vector map. In this function is almost the same than the previous one, with the figure creation, the addition of the figure, some commands to plot the data, and in these commands to plot the data, we have plotting the magnitude as with the calculation of speed like before, right? But after this, in this block of the commands to plot the data, we are including these commands to plot the vectors. This is to do that, we are using the Quiver function from Matplotlib. Here you should have the link for the documentation of Quiver. The Quiver is just a function devoted to plot vectors in maps in any plot. So the parameters you have to give it to Quiver is the values of the position of vectors and also the values of the components of the vectors, right? So that's what we are doing here. We are passing to the Quiver function first the position in the u direction, the latitude, the position in longitude, and also the components v and u, right? And what are doing these commands here? What is its purpose? Well, this is a little bit difficult to explain right now, so we will skip this by now, and we will explain later when we see the result of this map. Well, the final block is just to add the titles and the legend of the map, so we can run this.
Sorry to interrupt you, Alvaro, just to let you know that it's now 1 hour in. You are already for an hour in.
Okay.
Just to keep track of that. Thank you.
Okay, I'm sorry. With this, we are plotting this map of vectors with the Agulhas current is very clear, and it's showing the direction of the vectors, and with colors we are showing also the speed of the current. And also it's interesting to see what is the purpose of this skip parameter. With these variables, with this selection of data, we are selecting some data inside the data. You can see this variable skip is included as a parameter in the function, and this skip is this value, actually 5. Let's imagine that we do not skip values in our map when we run the cell. We would obtain this, which is quite messy because obviously there is a lot of vectors plot here because the resolution of the product is very, very high. So we will get this mesh that is not very helpful at all. So to plot this, we should find an equilibrium between how many vectors we can skip. Because, for example, if we plot 25, we skip 25 elements. We are plotting every 25 elements. We obtain this, which is actually also not very convenient because they are very few vectors. It's better to find an equilibrium between too much and too many. And for example, 5 is, I think, is quite nice, right? Well, there is a final example, which is animate maps. This example, I think, it's not very, it's interesting, obviously, but it is just to make an animation of different maps of velocity. You can run the example very fast. We are doing exactly the same than before. You can see, we are selecting the data for a period of time. We are making a plot, a loop to make many plots. You can see we are using the function we defined before, so we can run this, and this is creating some figures here in the figures directory. There should be appear here. Why is there is a way to refresh this? And well, after we have created these figures and this path, I don't know why these are not appearing here. We use some Pythonic functions, not very related with Copernicus Marine, to make a GIF animation. So we can run this and we get this is a animation for a period of time, right? Well, this is the finishing of the course. Well, this is the final exercise. I think it's quite difficult for beginners. Well, it's to create an animation of SST for a period of time, but I encourage you to face this exercise. I think it's feasible. And this is the conclusion, right?
Great. Thank you very much, Alvaro. I think it was very much appreciated by the comments I've seen on the chat. I think
Sorry,
it was really nice. And also no, it was perfect. The pace was also very good. I think it was a nice pace. I have already a few questions for you if you're happy to answer them.
Good.
And so just remind everyone, even if you're not able to follow what Alvaro was showing us, you will be able to see it later on. And okay, can you maybe see my screen very slowly? So some of the questions are a bit general, but
yeah,
it would still be nice for you to, yeah, you address whatever you're able to. Can we do the tutorial in Google Colab?
Well, right now, not. The answer is not. Actually, I am not very sure what is Google Colab. I don't know if it is some kind of programming languages or.
I think so. Yeah, I think so, but I'm also not 100% sure.
Right now,
it
is not for sure. It is not available. We can think on that for future training courses or for future tutorials. It would be interesting, right?
Yeah. Well, yeah, I guess the best option would be to, just like you explained it, right, to download and work on your own Jupyter environment. Yeah, great. And the next one. Oh, so what is the difference between downloading the data from JupyterLab and MyOcean platform? Or some data sets are not available on MyOcean platform?
No. Every data set is available in both platforms. But the difference is that, well, today I just showed the beginning of the path. Python is a very, very powerful tool. So if you are interested in just the visualization of data. Maybe it's okay for your purposes. Maybe it's okay with MyOcean platform. But the real interest of using Python, I think, is that you can make very, very, very complex analysis, and you can start to use complex mathematical tools to make an analysis of the data. Maybe in the next tutorial, we have seen right now, we have seen just the beginning, which is the access to the data and the first visualization. But in the next tutorial, maybe it's a bit complicated for many people, but you can see the real power of this tool. There is an option to make a complex mathematical analysis of the data, so you can plot variables that are not actually stored in the platform.
Mm-hmm. Thank you. And so a question between MATLAB and Python, which one is more effective and easy for ocean data analysis?
Well,
if you have experience with MATLAB.
It's quite polemic, because surely there will be a lot of people that will defend MATLAB or Python.
Yeah. Okay, we don't want to start a war now.
Yeah.
And R, there's also R that can come in the head.
Yes, I would say that the main difference between MATLAB and Python, they would have many differences in computational approach, but MATLAB is a property code, so you have to pay for the license, for a license of MATLAB. You should do it.
It's not free.
But in the case of Python, it's an open source system that you can just download and use it. And so this is from my point of view, the power of the Python in front of MATLAB. In terms of computational efficiency, maybe MATLAB is a bit more efficient, but this has the advantage.
It's advantages and disadvantages, I guess. Yeah. Yes, thank you. And can we change the bathymetry of the maps?
I don't understand very well how could we change. We can plot bathymetry. Actually, my partner Stefania will show the bathymetry of maps in a few minutes. You can change it as soon as you can change any data you have in your database, but I'm not very sure what means change the bathymetry.
Yes, yeah, exactly.
You can plot the bathymetry, and you can get the bathymetry and get the data and see the data.
But the data is already how it is, so you can. That would mean change the data, right? Or have other data. And one last question, how can we copy these scripts to one file that can be executed later or on our own hard disk? I tried to do a simple copy paste, but it does not work.
Yeah, I think it would be interesting to, if you are user to work with Jupyter Notebooks, you can download the Jupyter system and install the Jupyter system in your laptop or in your PC, in your computer, so you can run the exercises and you can run your own code. So this is another reason, because I wanted to include some functions. Maybe it's a bit more obscure if we write things in functions, but the good thing in functions is that you can copy that part and put it in your code in your Jupyter system, and it will work. The function is like a file, so it works. It's independent of the rest of the code.
Okay, so it would be possible to do that.
Yeah. Actually, it's a video that we should make someday, is how to install Jupyter in your own platform.
Yeah,
so you can run in your own
steps.
platform the tutorial. Would be interesting.
Actually, I think we already have one, but maybe Cedric can confirm, or Anaïs. From the user support team, I think we have a a beginner guide to the Jupyter lab, and yeah, I'm not sure, but maybe Anaïs, so Cédric, if you're there, you can confirm that.
Yes, there are different online resources to have users on this topic.
On the Jupyter lab,
Yeah.
right? Yeah, I'm pretty sure I saw Elena on one of these videos. I will actually share it here. Thank you, Cédric. Great, and oh, I think there's also another question, but I cannot display it in full screen. Can the Jupyter Lab script also be run in Spider? Our local internet speed is slow, so Jupyter often lags. Thus, on an offline program like Spider works better.
Well, you can get the cell codes. You can copy the cell codes and paste in a script for Spider, and it should work for sure. It's important to take in consideration the libraries you have already installed in your system in Spider, because as you know, if you are working with Spider, you probably know that before using a library like Cartopy, for example, you need to previously install the library. But the internet is full of information of how to install this kind of libraries in your system.
Thank you. And I think we did this one. Oh, yeah, one last one. How to plot the seasonal maps with ocean currents.
Oh, very interesting. I think I would say that to Anonymous, it has no name, that in the next tutorial we are going to compute the monthly means of data for a period of time, and we are going to work with a very long, I think 1 or 2 years of data, and we are going to compute the monthly means of those data. So at the end, the computing of seasonal values is almost the same. Is not computing monthly values. It's computing 3 monthly values. So later in the next tutorial, I will make a little comment about how can we do this and how can we plot this actually.
Okay, great. So yes, we are good for our questions for now. And yes, so it's now 12:15. I'm not sure how much time you had reserved for the intermediate tutorial, Álvaro.
Well, we can start with the intermediate tutorial and
I can stop you.
yeah, I'm sorry.
No worries. I mean,
actually, in the intermediate tutorial, I want to spend so much time on explaining the environment and etc.
Sure, yeah. So yeah, don't worry. I will stop you then whenever we are running out of time, and we can always get on our break.
Okay.
We will just continue. Great, thanks a lot, and whenever you want.
Let me share my screen again. This one. You have my screen, I think.
Yes.
Well, this is the tutorial we ran before. I'll try to go a little bit faster. So now we are going to close this tutorial, and we are going to start with the next one. This is the intermediate tutorial. Here, this tutorial is devoted to give to the users some tools to manage for management that could be applied for fisheries, for example, or for coastal management. So in this tutorial, we are going to focus in the analysis of surface temperature, and this is done focused in the analysis of the upwelling system. So we are going to provide an analysis of the upwelling system oriented a little bit to find regions where the upwelling are more active. So So it could be helpful for fisheries, so they can find. Let's see later. And we are going to see the waves of the region. We are going to provide an analysis of the waves. And why have we selected the waves? Well, because waves are one of the most important parameters that usually affects the human activities, right? And we also are going to give some tools for analyzing the currents in the region. So, well, let's start. This is just an introduction that I did before, the Angola-Benguela system. Well, and this is the first cell of a Python system. You probably know what are these kind of cells. For this tutorial, I would say that to run these cell codes, you can click on this play button. So once there is an asterisk, and now when you see a number here, the run has already, the cell has already run and is already loaded in the memory of the system. I'm going to collapse this. And well, we have the first setup of the Python environment. You can see we are using here these libraries, the NumPy and the XRI. The NumPy library is set for mathematical computation. The XRI use it to open and manage netcdf files. And we are using 3 matplotlib sub libraries. And also we are using Cartopy to plot maps again. And we are using a new library, which is WindRose. Is a simple module to plot polar rose plots. We will see later what is this polar rose plots. Well, in this tutorial, we are not using just one product, Copernicus Marine product. We are using 3 Copernicus products. Here you can see, you can have the parameters we have used to download the products, because as in other occasions, we are not going to spend time in explaining how to download this data. Let's say that this data is directly stored in this directory. And well, in this cell, we can run this. We are just assigning 4 variables and assigning the path and the name of the files we have with the data. You know, we have this 4 data. Data from temperature, from the analysis and forecast system with 1-day frequency. We also have data from temperature, but this is the multi-year system. This is the reanalysis with a monthly frequency, and we are going to use also data from the wave systems analysis and forecast in hourly. It's not hourly, it's 3 hourly data. From currents from the global physical model, we are going to get the analysis and forecast in 1-day frequency, right? First of all, there's a very short description of what is an upwelling. When we have a coastline and the wind is blowing in parallel to the coastline, sometimes depending on the hemisphere, the Ekman transports goes in a normal direction to this wind. So when we get wind in the, for example, this is for the North Hemisphere. If we get a wind like this, the Coriolis effect pushes the water to the left. Oh, sorry, to the right. So when we have a wind blowing parallel to the coast, we have deflection of the water away from the coast, and this deflection is followed by upwelling of deep water that comes from deeper layers. That comes from deeper layers. It is cold water with lot of nutrients, rich in nutrients, etc. So here we are going to give some tools to analyze the temperature field for oriented to managing of fisheries. As before, we are going to start opening that data set. For example, this one, the temperature file, and we can run this. We have, as before, an etcdf file. In the previous tutorial, I explained it. What is an etcdf? How I explained it also the elements we can find in the etcdf, and we can make as first approach. We can make a plot of temperature, surface temperature. To do that, we can select the slice of the data as just the same than in the previous example. And once we have selected a slice with values of latitude and longitude, but just 2 dimensions, we can plot the data using a function very similar than the function we used before in the previous example. The only difference is that we have included the creation of the figure and the axis outside of the function, right? So the function gets as parameter the axis and the data to plot and the title, right? So we have to previously create outside the function. We have to previously create a figure and the axis with the corresponding projection, geographical projection. And we use the plot map function to create the map, right? We can go with this, we can run this all. Well, this is what we get, an image of temperature like we did before, actually. It's very nice figure, but well, maybe sometimes it's not enough if we are interested in well, how much intense is the upwelling in some specific region. Well, we don't know. We can see this image of temperature, but it's not actually the how much intense is the upwelling is not represented here, because we are having just temperature, but actually we are saying the upwelling is strongly affected by the seasonal variability. We don't know. Maybe we could say, well, here in 25 degrees latitude, we have areas with very cold water, but let's say, so we can, as other view of the upwelling, we can also plot sections of temperature. To do that, we have to make a new selection of data. This is something that we have not done before. Here you can see we are selecting a range of values of longitude. And since we want to plot a section of data with depth, we are selecting a range of values of longitude and just a specific latitude. So we will get a zonal section, and with this cell, this command is nesting two cell functions. First of all, we get the information from the data file with the variable, and we are selecting the range of latitudes. To do that, we use the slice function, and we put the slice with the minimum value and the maximum value that are stored here in this list, right? And after that, we are including the selection of latitude and time values. You can see this. We have wrote this in this way because we think maybe it could be more clear for users, but this is actually, let me show you in this way, just in case someone doesn't think this is more clear. Well, these two functions, these two lines are exactly the same. That's exactly the same. You can write this sentence in just one line, or you can write this sentence using this slash at the end here to split a line in different levels, and maybe I think maybe it could be more clear this way of writing things, but well, probably it's not the same for other people, so you can use the same. Use both of them is exactly the same. In this case, we are using this, and with this command, we are getting, you can see an array of data to section with two dimensions. This time we do not have latitude and longitude as dimensions. Obviously, we have depth and longitude as dimensions. And with this code, we can plot the section, right? We run the code, and let me explain you that here we are creating the figure and the axis. This is this in this plot we are including two panels. The left panel, it's including just a plot of the surface temperature, a map of the surface temperature. So to do that, we are using this plot map function that was defined just before. This is the great power of functions, that once they are defined here, we do not need to write any code here. We can just plot map with the axis that have been previously defined and use the data and the title, and we get our plot map. And over the plot map, we include this little plot, which is this red line, the dotted line, a red line to show where are the latitude we are selecting. And well, what is really interesting is these lines. In a second subplot in the panel, we are including a contour plot. This is a function. This is a Python matplotlib function to plot contours like this, and we are including some addition of the figure. For example, we have to invert the axis to find the higher values in the bottom and the lower values in the upper place. We also modify the background color, which is this gray color here. We also include the latitude and longitude labels and the title of the figure, and obviously the color bar, right? So we get this result. So what is interesting is actually more interesting is this. Well, what are we seeing here? Well, here we are seeing the section of temperature along this this line, right? So, well, we get, you can see that there is the isothermal lines. And when we go closer to the coast, the isothermal lines are curved to the surface. So this is the actual effect of the upwelling. The water is moving towards the inner ocean. So the deeper water is upwelling from the bottom and going to the surface. So that's the reason, because of this is the reason of the decreasing of temperature in the coast, right? Well, this is interesting, very interesting information, and we could run again this code, changing the latitude and the longitudes to analyze the upwelling. But from our point of view, we are still not. We can do it here, 25.5. We can run in the, as we said before, in the 25 degrees latitude. We can run here. One second. Well, we get this information of the curvature of the isothermals. So you can see that the effect of the upwelling also reaches quite depth, up to 400 meters depth. But this information doesn't give us information about how intense is the upwelling. Is the upwelling in terms of productivity? That's because, as I said before, well, this is cool water, but taking in consideration that the upwelling has important annual variability, seasonal variability, we should take this in consideration, so we can consider how intense is the upwelling just in terms of taking in consideration the seasonal variability of the upwelling. To do that, we are going to start working with anomalies. The definition of anomalies is just the removal of the mean value from data. You have a temporal time series. You have time series. So in the moment you get this time series and you remove from your series the mean of the series, you transform your time series in a time series of positive and negative values that goes around your mean. That indeed that moment your mean is 0. So to do this, we have to compute the mean to remove the mean from the time series. So we are going to use another data set, which is the data set provided by the multi-year system, a very long system, so we can get a very long period. You can see here we have 132 data for a period of from 2010 up to 2020. Well, we have 20 years of data in this data set. So we are going to use this data set to compute the monthly mean. So with this, we are going to have the monthly mean, the seasonal oscillation of temperature, and we will be able to remove the seasonal oscillation of our data, and we will be able to analyze the data, not taking into account the absolute temperature, but taking into account how much intense is the upwelling in.
Hello, Álvaro.
Yep.
Are you there?
Yeah, can you hear me? Hello, Andrea, can you hear me? Andrea? Andrea, are you muted? Can you hear me? Creo que hemos perdido la conexión.
Alvaro, I'm Cedric, I can hear you. no problem. Maybe it's an issue with Andrea.
Ah,
Oh,
okay.
is it just me?
Ah.
Oh, I'm here. Okay,
Yes,
sorry.
you're here.
I thought it was.
No
Oh, whatever.
problem.
I'm back. Sorry for interrupting you. Go ahead.
I was starting to chat.
You froze on my screen. Sorry. Sorry about that. Carry on.
Well, we can continue. So, well, our objective was to remove the seasonal oscillation of our data, and we were computing the monthly mean of the temperature for a long period of time, 10 years. We have already opened this multi-year temperature file. With this cell, I think it could be interesting for the person that previously asked it about how to compute the seasonal means of your data. And since you have your seasonal means, you can plot your seasonal means, right? So in this case, we are not computing seasonal means. We are computing monthly means. That it's almost the same, right? Let me explain you. First of all, we are creating a new variable that we have called monthly mean, and this is the way we are creating variables in XArray. It's a data array. We have to define the dimensions we are going to use. We are going to use the same dimensions that in the other files. We are going to use depth, latitude, and longitude, but in this case, we are going to create a new dimension, which is month. The month is the month of the year of the mean, right? And after that, we have to define the coordinates of the file with this dictionary. I think this could be. Okay, this and this. We have defining a dictionary with the coordinates with the dimensions inside. So we are using depth, latitude, and longitude, and since all the dimensions in that direction are the same than the dimensions we are using in our model file in the multi-year data set, we are just copying the dimensions by using this. The depth dimension of this variable is exactly the same than the dimension depth in this variable in this data set. The same for latitude. We are copying the latitude dimension from the multi-year data set. Longitude, copying the dimension, and for the case of the month, we are creating just an array of values. Why is this from 1 to 13? Let me. If we run this cell in Python, nprange creates a vector of values from 1 to 12, not 13, right? So, for example, the person that is interested in plotting or in computing this, seasonal means, it could be, for example, use 1 to 5. And this would create a new dimension with 4 values, just 4 values for spring, autumn, summer, and winter. And with this, you need 4 values in this dimension. And well, once we have created the variable where we are going to store our monthly mean, we have to compute the monthly mean. To do that, we make a for loop for every month in the year, and with this we are selecting. With this sentence we are selecting. We are using the function from NumPy where this function gives us the index of the values that is where this sentence is true. So in those values where the month is equal to the month we have defined here, the monthly mean or month 1, 2, 3, etc. In these values that has this true, we are computing the mean, right? In the dimension time. So we are selecting every value that has this condition with iCell. We are using the iCell. The iCell function is a function devoted to selecting data not by values but by indexes. With these cell time indexes, we are selecting we are getting the indexes that has this condition, and we are using these indexes in the time direction to select the values that has these indexes, and for these values we are computing the mean, right, in the dimension time, right? So as you probably saw, we have the for loop for month 1, 2, 3, January, February, March, etc. And when the system, the function finishes, we have this date file, which is depth, latitude, and longitude, and the month. And we have the mean value, the monthly value for this block of data of depth, latitude, and longitude. And well, once we have this, the only thing we have to do is to compute the anomalies. So how can we compute anomalies? Well, here I define it, a new function called compute anomalies that gets the information of the data, the multi-mean of that we have already computed, and a date. So we can compute anomalies with a sentence like this. We call the function compute anomalies for this date set and this variable in the date set, theta, which is the temperature, and using these means and for this date. And what is doing this function? Well, it is just selecting data, selecting the data according to that we need a specific date. So it selects data from data, which is the values of temperature. And maybe it's simpler if we go like this. Here we are selecting the values of temperature, and here we are selecting the value of monthly mean, right? How can we select this? We can select this using the date we need. And to select the month of the year, we have to first define what month is for this date. As you can see here, the date we are selecting is in this format. So to do this, we can split this chain, this string, in splitting using this character. So the first word of this splitting will be the month of the year, and we will read this value as an integer. So with this information, we can select the month of the year we are working on. And to compute anomalies, it's, as I said before, quite simple actually. It's the value of the data, the temperature in this case, and the value of the mean, the monthly mean in that case. So with this, we are removing the mean of the month of this year. With this, we are removing the variability of the seasonal variability of data, right? So since we are computing the anomaly.
Sorry, Alvaro.
Yeah.
maybe a few more minutes, like 5 minutes. Would that be okay for you?
Well, well, yeah,
Just to give some time for the next
I
one.
think I can. Okay, I will skip the part of the current that is very similar, but well, we'll go with this.
Just
well,
finish this section. Would it be maybe possible to finish this section and maybe we pass it on to Stefania soon?
Okay,
Yeah.
no problem.
Okay, thank you very much.
Well, with this, we are computing the anomalies for the currents, and well, we can run this solve. And with this, we will have the values of anomalies computed. And with this, these functions are very similar to the functions that were defined before in the previous tutorial. It's just a function for plotting anomalies, a map and a section. So we can run. And with this, we are getting this information. As you can see, it's almost the same than before. But for example, for the case of 25 degrees, the activity here in these maps, you are getting the information with the anomalies in terms of temperature. The positive anomalies are red colors, the negative anomalies are blue colors. So as you can see, probably the activity of the upwelling is not as intense at the latitude of 25 degrees, is probably more intense in this latitude, as you can see here. And here you can see the tips where you can have the more activity of the upwelling, and you can see also if these depths correspond to the depths, well, the photic depths, let's say, the depths where the primary production can be developed. For example, I will run this very fast on 27 degrees, for example. 27 degrees. Let's imagine we can. For example, here you can see that we are getting a cell where the upwelling is more intense. This period of time is, you can see clearly, and you can see this cell. So probably the fisheries in this region, the specific surface and these specific depths are higher than will be higher in this period for this period, right? Well, we are going to jump very fast to the analysis of waves. Waves are also another parameter that highly affects the human activities, right? So I wanted to give you some tools to analyze the waves. For this, we are opening a new waves file, a new data set. And what we are going to do in here is plotting a map of the mean direction of waves. You can see here we have a function called vector map, which is almost the same function we defined in the previous tutorial. This takes some time, usually. With this, as before, we can get very interesting information, but well, having the information of the mean wave direction and wave intensity, maybe it's not very useful because the waves have a very high variability. So this is taking too much. Oh, here it is. But well, it could be interesting. But so one thing that we can do is put in a wave rows diagram. That is a diagram that, let me show you how is it, and it will be easier and faster to explain you how can be understood this kind of diagram. In this kind of diagrams, we are plotting an histogram of our data, but we are representing this histogram in a polar axis. So this is what we get. The Rose diagram is defined in a specific latitude and longitude point. And here in colors, we have different ranges of, in this case, a significant wave height. So here we have the histogram projected in polar axis. So we have the frequency, the size of these boxes indicate the frequency of these values. So with this, you can get a lot of information of how the waves field is the behavior of the wave field and the statistics, the variability, and also the intensities, right? This kind of analysis is very useful for many applications, and also it's also interesting because you can apply this analysis also for any vectorial variable. For example, in the case of currents, here we have another data file of currents that we can open, and we can also run the same code for this case, for the case of currents, and we can plot not the wave rows, but the current rows, right? It takes some time. Well, we can, for example, here for the Agulhas current, we can get this very obviously there is not many directions because we are selected in a point like here, and we have very intense values in climatic approach. And finally, just I wanted to show you the combined analysis of currents, waves, and temperature. We can make a combined analysis. So with this kind of tools, we are able to analyze a field, not from just one point of view of the temperature or of the waves. We can create tools to analyze our field of data from many points of view, with a multi-variable approach, with multi-product approach, and also with different approaches. We can create tools like this that are where we are able to analyze the temperature field, the vertical structure of the temperature field, and also the waves, and also the currents in this place. For example, here you can see the currents are more variable in this area than in this area. Well, this is a tutorial. I hope it's interesting for you, and these tools could be interesting for your workflow every day.
I'm sure it's going to be really useful. I mean, I'm sorry I had to cut you. It's very interesting, and you will all be able to follow it more in detail. Also, these notebooks, you will be able to follow it on Jupyter Hub.
They are, I think, quite well explained in the text, so any user can follow the tutorial, and every code line is explained, and I think it's not difficult for...
Exactly. Per step, you have a short explanation on what they're going to find and what is expected, right? So yeah, you'll be able to find it there. Thanks again, Alvaro, for this explanation.
Very welcome.
And now we will have Stefania Ciliberti, who's gonna show us a little bit about how to use Copernicus Marine products with QGIS software. Yes.
Hello, everyone. Oops.
Just to let you know, Stefania, I will probably stop you around 1:30, if that's okay with you, so that we don't pass too much our time.
Okay, so hello everyone.
Thank you very much.
And welcome to this no problem, to this training session about the QGIS. And the main intention of this set of exercises is, let's say, to give a complementary overview of what before Alvaro explained about the region of interest that we are proposing today to you all, that is the Angola-Benguela system. Quite, let's say, important and complex as many other regions in around Africa, in the, let's say, being so, let's say, connected, well connected with many important, let's say, ocean sites. And this is also to, let's say, to comment one of the requests from the panel related to the way we can use, let's say, the Copernicus marine data also in other regions. Of course, we can, and let's try, let's say, to take these exercises really as examples of what are the potentiality that with the Copernicus marine data and with the tools that we are going to present, we can really do. So you will find regarding QGIS some initial details about how to install and how to configure the plugins that today I'm going to use and to show you in live mode into the user manual that I guess the people that are registered might have access. So to save some time, I want to jump directly into the exercises and exploit basically the capacity of QGIS to provide some advanced visualization of the Copernicus marine data. To do this, first of all, of course, we need to open the GIS tool. Let me just, one moment, I don't know how, I hope you can see my screen, but I have the right panel of Zoom that is giving me some toolbars. So if it's okay like this, and you can see the QGIS window, I prefer to leave like that. Basically, first of all, I need to give some context in, and even support the representation of the geographical information. Let's exploit one of the plugins that has been presented in the user manual, that is the Quick Map Services. This basically provides a plateau of base map that we can use just to put as background to our maps. And in my case, I would like to use the Google Hybrid that gives basically a natural overview of our ocean, and with some, of course, indications about with the labels of the countries that, let's say, might help in the geolocalization of the sites that we are going to display. And let's move now into the one of the, let's say, capacity of the QGIS together with one plugin that is also detailed, that is called CMEMS NetCDF. This is a plugin that you can install in QGIS that is made available by the Copernicus Marine Service. The description on how to configure, how to install it is also provided in the user manual. And this plugin gives us the opportunity to, let's say, load the NetCDF files directly downloaded from the Copernicus Marine Data Store and made some, let's say, easy visualization of the contents in an easy way, in a more user-friendly way, but also making some, let's say, initial manipulation. And I'll show you some examples. So once you launch the plugin, this window is open, and in the tab related on the NetCDF, if you click plus, you can browse into your working folder and select the data from the Copernicus Marine Data Store that you have before downloaded. In my case, I would like to propose you one of the observational product that was presented yesterday during the first day of training, that is the sea surface temperature L4 presented by Andrea. And in particular, once you load this file and you have the name and the path on the left side of this window, automatically in the right side, you have the refreshed list of variables that this netcdf file is loading, is proposing basically, and together with some other tabs related on metadata and options that might help you simply to define your working space. Of course, we are interested to visualize the analyzed SST that is provided in Kelvin. This is the sea surface foundation temperature, and to load it inside the QGIS, simply you can select doing right click and add it as a layer. Through the Motu client that was presented today by Alvaro, extensively also by Cedric and by Anaï, through the MyOcean Pro visualization tool, you can of course select the bounding box you want. Being a global data set, so covering the whole global ocean, I mean, it's, let's say, clever to exploit the capacity of the marine data store to subset in the region of interest. And this is what I have done both in space and time. And in particular, for this file, I have 4 timestamps. I will select one of these, that is the 10th of April, during which the upwelling start to spawn. And without, modifying any of these settings that by default are proposing by the plugin, and I add, as you can see here, automatically the map being georeferenced and being also in a standard format is automatically displayed into our map. We can, of course, modify the palette of this map, simply highlighting it, selecting it, and doing right click with your mouse and going into properties. Into properties, you can select now the way you want to display, the colors that you want to use for displaying this map, as well as the minimum and the maximum value that the palette will display as well. Just for matter of being practice, we can round the minimum value and the maximum value of this data set, and we can select as color ramp, for example, the turbo. We can provide, let's say, as way to display the full color map with equal intervals, for example, using 7 classes. Of course, you can play, and this is also a way to encourage you to, let's say, explore the capacity of this software, even for displaying other type of variables, as I'll show you briefly later. Doing applying and closing, we can see that the map has been adjusted in the color, where basically the colors towards the blue are related to the temperature that are colder than the other regions where the colors are going towards the red, which means that instead the temperature, the sea surface temperature, is quite high. This is basically the sea surface temperature observation that is directly taken from the satellite. And as yesterday was explained by Andrea, this is one of the way we can, let's say, reach the synoptic scale of the temperature in this case for the at the surface. And it's quite powerful, and also gives to me the opportunity to introduce you another function of QGIS that is related on, I might be interested to convert the sea surface temperature here provided in Kelvin to Celsius, in order, for example, to make some comparison later on with the model data that provides the temperature in degrees Celsius. To do that, you simply can go into the raster toolbar and select the raster calculator. It displays a new window that gives to you the opportunity to do simple arithmetic expression. In this case, I select the only available field, that is the analyzed SST for the 10th of April. And basically here I subtract 273.15, that is the conversion factor for moving temperature from Kelvin to Celsius. I decide to give let's say the name to my new product in a dedicated working folder. For example, I call it SST Celsius in my working directory. And if I do save, automatically the path is loaded together with the file name that I have chosen into the output layer slot. And if I do OK, being only one timestamp, the calculation is quite fast, but of course with QGIS you can even, let's say, analyze many other, let's say, time frame from your SST field. In this case, the color map is not really the best for visualizing temperature that goes from 12 to around 30 degrees. So again, with right click and going into properties, I can modify first of all, the render type to be single band pseudocolor, because I want to visualize the values with some color map. Set up manually, if you wish, the minimum and the maximum value for the displayed palette, and use the equal interval mode for representing the palette with 5 classes for binning the temperature value. I do apply, and doing OK, the map is refreshed, and so you have the same, let's say, information, but this time in degrees Celsius of the sea surface temperature from the satellite. And here you can easily, as before was also, let's say, mentioned by Alvaro, we can easily spot the cold signal of temperature that is rising in the Namibia, South Africa coastal zone, which is extremely important from a coastal management point of view, but also from the ecosystem point of view, being a place where basically it's devoted is, let's say, ready to host, let's say, some life, in the sense that it combines, it gives to us the opportunity to see some growth of phytoplankton in this specific region. And so where we can potentially find some, let's say, fishing spots that can be and should be sustainable, preserved in our ocean. And the upwelling is characteristic because you can see, even from just giving a visual, let's say, feeling of this through this map, that from the coastline towards offshore, we might have even more than 5 degrees of difference. In the sense that the coastal zone is really quite cold. And this is one of the results of the Benguela current that flows into the Namibia, South Africa coastline, and that somehow, as it was before also described by Alvaro, met basically the Angola current that is flowing from the north toward the south in the so-called Angola-Benguela frontal zone, which is a zone thermodynamically very unstable. But through this, let's say, plugin, we can also link other type of variables that might be extremely useful to monitor when we do some spatial monitoring of the coastal or of the regional area that you are interested to monitor. And in this case, I want to load, for example, another Copernicus product that is the one provided by the Global Ocean Analysis and Forecast Biogeochemical System that yesterday was described by Coralie. And in this case, I have been selected three major, let's say, variables: the concentration of dissolved oxygen in water, the concentration of chlorophyll in the sea, and the net primary production. Let's see how it looks like the chlorophyll for the 10th of April. Again, we add it simply as a layer. We select the day of reference that we want to analyze, and doing add, basically the map is visualized in the area, in our study area, and you can see here basically that thanks to this cold water and the light, basically here the concentration of chlorophyll is extremely high. But on the other side, of course, if this is important from a physical point of view, on the other side, from the if we look on the ecosystem health, this might be also an alarm, a threat, because we might have zones here where we might face some let's say, diminishing of the oxygen. And in this case, when during the spawning of the upwelling, we can see that in this region where we have the highest concentration of chlorophyll, we might have, let's say, a reduction in the oxygen that is present in the ocean. Let me add now the field about the oxygen. Let me just change the palette because this one doesn't work very well for our purposes. Let's fix manually the minimum and the maximum, for example. And here you can see we might have, in the area where we have the highest concentration of chlorophyll, sort of diminished amount of oxygen in the water. And you can easily, let's say, query the map by selecting this identify feature. And once you click into the map, you can, let's say, for that specific pixel, recognize the amount of dissolved oxygen in the water that is provided in millimole per meter by meter cubic in the ocean. So this is somehow a way to display in a powerful way the Copernicus marine data through the QGIS. But of course, this kind of software provides us also the opportunity to make some analysis, in particular of the data that we are downloading from the Copernicus Marine data store. And this is the case I want to show you. Basically, let me just deactivate these, let's say, these fields. For example, you might be interested as, let's say, stakeholders or students, researchers. I mean, when you have to deal with Earth system models and you have to, let's say, manipulate some modeling or observational data set or even set up new models, the first thing we need to do is really to know the region where we are working. And in particular, this can be extremely easily to be done if we select, for example, the bathymetry that is provided by the Copernicus Global Ocean Analysis and Forecasting System that yesterday was presented by Marie. And then through the plugin, the CMEMS NetCDF, let me go to add another file. This is the MaskBATY, the one that directly comes from the Global Ocean Forecasting System. And if I do simply open and I load it, automatically I can see the list of variables that this file is going to provide to us. I am interested mainly on selecting the seafloor depth below the geoid. That is the depth of I add it as a layer. And without, let's say, touching any of these settings, I do add in my QGIS software. As pointed also into in the user manual, the majority of the Copernicus marine data are accessible through many interfaces, including Motu that gives to you the opportunity to subset automatically directly from the marine data store. But this type of product, like the bathymetry, for example, might be being, let's say, some files that are native of the model that is used for producing the analysis and forecast product might be provided in the global, in the real spatial domain that is, let's say, given by the product catalog. So in this case, I might be interested just to subset by myself, with the help of QGIS, the bathymetry in the area of interest. To do that, somehow also gives to me the opportunity to present you another function, another important function that any type of GIS, Geographical Information System, has, is the creation of a layer. A layer is an object, basically, that might contain some information in pixel, like a raster, or might have also some other metadata inside, as we will see later on, let's say, as a vector. But here, let's start to simply progressively by creating a new layer. And I want to add a new shapefile layer in my QGIS software. First of all, once I click like that, a new shapefile layer window is open. I want to give, for example, the name of my of this new object in the working directory that I am using for saving all my intermediate results. For example, I call it MaskBati. And I need to choose which type of geometry I want to create. QGIS gives to me the opportunity to create points as a shapefile, or multi-point, or even lines or polygons. In my case, since I want an area, I'm interested to figure out how to create a polygon shapefile here. Automatically, the QGIS is able to recognize which is the projection that is used by the source field, that in my case is the global bathymetry. And simply doing like that and doing OK, you can see that in the left panel, in the layer controller, the MaskBati object has been created. Of course, now we need to give to it a shape. To do this, let's go in the toolbar and select the toggle editing. That is this icon with the pencil that activates the possibility to modify the MaskBati, the shapefile that I have been created. And once this is selected, an additional number of icons are highlighted in the toolbar. And in this case, since we want to add a polygon feature, we select this icon, then consequently opens another icon that gives to you the multiple choice in the way you want to digitize this type of shapefile, this type of polygon, by segment, by curve. I am interested very simply to use to digitize the shape. The shape will be regular in the sense that I want simply to extract a rectangular in the area of my interest, so in the Angola-Benguela system, but of course we might do the same in the Algerian Gulf, as before was asked by one of the attendees, if I remember correctly. And let's do, let's draw now into the map directly this shapefile, doing a click. This feature is, let's say, created automatically. And once I am happy with the type of shape that I'm going to create, I do right click. I provide an ID just to let QGIS to, let's say, classify this MaskBati with the proper number that identify it. I'm doing okay, I have created this rectangle. Of course, I mean, I can continue to customize the mask body in a way that, for example, gives to me the opportunity to have a look on what we have in the background in the map. In this case, I want to use an outlined red but transparent rectangle that gives to me also the opportunity to watch at the bathymetry in the background. And once I'm happy with this, I simply deactivate the toggle editing, saving the result of my elaboration, let's say. Now, just one step before the end, we need now somehow to connect the bathymetry given at global domain from the Marine Data Store with the specific object that I have created. So doing a sort of cut of the bathymetry into the area of my interest. To do this, I use again from the raster toolbar a function that is the extraction. And in the extraction, we might have different, let's say, opportunities, different options to define it. For example, I would like to clip this raster by using the mask layer that I have created. So I give as input layer, in this case, the global bathymetry that I previously loaded thanks to the CMM SnapCDF plugin, and the mask body that I just created right now. There are some other optional things that you can set up, which I recommend in any case to check because it's related on the projection that you are going to use in this case for the final, let's say, product. And once you have set up basically the same projection as the input field, you do run, and doing close, automatically the bathymetry is clipped in the area of my interest. I can now move on by customizing again the palette. I'll go very fast because it's something that we have, at this moment, we have learned how to do. So I'll use a single bound pseudo color with a minimum value, for example, of 8 meters and maximum of 5,700 meters. That is the maximum depth in this region. So you see that it's a very, very deep region. And as color map, for example, I use Viridis with equal intervals. I'm happy with 5 classes, so I do OK. And automatically, the palette is adjusted with minimum and maximum value as displayed in the palette on the left. Of course, I mean, this is a way to, let's say, even to optimize and to exploit the QGIS function for those data sets that might be present in the Copernicus Marine Data Store that are not interfaced with any subsetter. So, but in any case, you can use the approach of clipping can be applicable for any other scalar field that you are interested to use. And just to conclude this part, I would like to show you another function, another plugin really that I suggested to install in your QGIS software, that is the terrain profile. The terrain profile basically somehow would like to do something quite similar to what Alvaro was showing before, even if in the case of the bathymetry, having just a 2D field, what we expect is simply a profile of the bathymetry in a specific section. But let's see how it works. So once it is activated, basically, a new window is open below the map, and let's say to query now with the profile tool this map, I need to add the layer, as a layer, the clipped mask that I have been just right now created, sorry. And now by just clicking in drawing, let's say, a section in my map directly, I can visualize quite nicely the let's say, the profile of the bathymetry at this specific, let's say, latitude that is around 19 degrees south. And this is extremely nice tool because you can really detect the peculiarities of your domain. For example, the seamount that is this one that from, sorry, it's, let me draw again. The VEMA seamount that is really nicely represented by the model. So we can even appreciate the degree of details that the global ocean forecasting system is providing in terms of let's say, physical information, because it's using a bathymetry that is able to capture at its resolution of 1 to 12 degrees of resolution in the space some features that are fundamental, especially for monitoring the ecosystem health in the region itself, or also for doing some fishing management, let's say, in the area. And you can see here, for example, that this seamount, you can have a look that, of course, here I'm also crossing the Wallis Ridge, that is another very complicated bathymetric structure available in the region itself. So this is just to conclude a way, let's say, to extract in interactive mode some information from your bathymetric data set. But this applies, I mean, if I load the oxygen or the chlorophyll or the temperature, the same kind of, let's say, approach can be used, and the profile tool will return to you basically the let's say the sequence of temperature value or chlorophyll or oxygen given at specific latitude or longitude through a drawn section. So let's continue a bit, let's say, moving to another way of analyzing the data that might be of your interest, especially if you think to, let's say, to exploit the geographical information system in a way that basically can let's say, support the coastal management or the understanding of or giving to you some, let's say, support for the sustainable growth of your region, or if you are a port authorities and you want really to monitor a specific area in your domain. Of course, here, I mean, for us, the mantra of this training is the upwelling. So where basically we have the cold and nutrient-rich waters in the region, that of course brings also some important economical and societal impact because of the importance of the fishing sector in this region. And we know that from literature that usually the upwelling region that is quasi-permanent or totally permanent in the Namibian coastline is really interesting portion of the coastal zone up to 300 meters depth. So I want to use this number, this, let's say, the 300-meter depth as maximum reached by the, let's say, more or less by the upwelling, just to try to set up a tool that gives to me the opportunity to extract some metrics from the Copernicus marine data, for example, the temperature, that I can monitor along the time. So to do that, I first need to modify, I mean, to detect from the bathymetric data set this number. So filter basically the bathymetry and retaining only the layers that are up to 300 meters. To do this, basically, I need to convert my given bathymetry into a polygon. And to do this, so convert this polygon to a vector. So I'll use from the raster toolbar, and if I go to the conversion, I'll use the polygonize raster to vector function. As input layer, I give the clipped mask because it's the one that I want to, let's say, to manipulate. I can give a more reasonable, let's say, the name of the field. Let's call it depth O, like that is the standard name chosen by the Global Ocean Forecasting System to present the bathymetry into the NetCDF. And I want to save the basically the result into my working directory. For example, here I call polygon. Just so once I have set up this, I am going to run, and basically the result will be, as you can see, the raster has been somehow fragmented in many polygons that have an ID, contains a certain information. And of course, in this way, I can now, let's say, exploit the capacity of the, let's say, discretized information in these polygons to filter out the values that I'm not interested to analyze. But before doing this, it is recommended also into the QGIS manual to run another function that is available in the processing toolbar if you select toolbox, that is called fix geometries. This function basically has the capacity to automatically correct some potential, let's say, inconsistency due to this conversion from raster to vector. By simply, let's say, removing some invalid shapes that are not really meaningful from the geometrical point of view. I mean, it does a sort of correction a posteriori of your field. So I give to my fix geometries function as input layer the polygon that I want to correct, and I return a new file that I'll save into my working directory that I call fixed polygon. Okay, now that I'm sure that everything is setting properly, I run this function. So from the qualitative point of view, you cannot even appreciate, at least for me, it's really hard to appreciate the difference with respect to the other field, but I can tell you that for sure there are some differences. And of course, we are interested to work with this type of final product. And now I can, let's say, extract the information that I want. So doing right click in fixed polygon, so in this intermediate product that I have, and selecting filter, I can give an expression for the query, in particular for the field that I want to filter, that is depth O. So, as I was mentioning before, I'm interested to filter only the values of the bathymetry that are above 300 meters, okay? So I want to discard the deepest part of the regional zone that I'm analyzing. So the depth 0 should be greater than, in this case, 8 meters, that is the minimum value of the bathymetry, the resolved bathymetry from the Global Ocean Forecasting System, and depth 0 should be less equal than 300 meters. Okay. If I do like this, basically, as you can see, the map is automatically refreshed. And so all the other values that are below 300 meters depth are basically hidden. So are not part of my, let's say, analysis. Now that I have this object, of course, I want to, let's say, to focus much more the attention on one specific region of my, of the Angola-Benguela system, that is the central Namibia, one of the regions where usually the upwelling can be considered really as a quasi permanent feature over the, along the year. Of course, with some interannual fluctuations due to the, let's say, the temperature that might, let's say, of course, change because of the dynamical pattern given in this, in the region itself, in the coastal zone. So let's say, concentrate the attention in the region that is between 25 degrees south, 29 degrees south, I need to create a new layer. So a new shapefile layer. So again, let's go into the layer toolbar, create layer, and open the new shapefile layer. I give to my new shapefile a name, for example, central, pardon, I'll do it in my working directory. I do like this because otherwise, if you simply put the name of the file directly without giving a path, it will be automatically saving your QGIS folder, which sometimes is not the best, especially if you are doing some tests. So I recommend all the time before launching a new project, just to initiate a folder, a proper working folder where to host basically your files. Now I call it Central Namibia, for example. I save, and the geometry type is again a polygon, but this will be a different polygon with respect to what we saw before. For me, the projection is fine. The rest we can leave as it is. We do OK. So again, the object has been created. Now, as we did before, we need to draw in our map the region that we want to, let's say, analyze. And to do that, we activate the toggle editing. Once this toggle editing is activated, again, I can add the polygon features, but this time, instead of digitizing a shape, a regular shape, I want to digitize a segment because I want really to follow somehow the structure of this belt that I selected before with my query. And in this case, for example, I want to concentrate more or less my attention in the region that is between 25 and 29 degrees. So I start, let's say, drawing directly in the map. Let me try, for example, like this. Now, more or less, I mean, this is just as demonstrative of the function of QGIS. I give, once I'm happy with the shape, I do right click and automatically this window with the prescription of the ID is visualized. So I do OK. Now the shape has been created. And basically now I need to, let's say, to somehow to link this object that is related, this new shape file, with the multi-polygons that I have extracted before. But before doing this, I save the shape file that I have just created. Now that I have these two information, through the vector toolbar, because what you have in background is a vector now, I select the geoprocessing tool and I select in particular intersection. The intersection, basically, what we'll do is to intersect the two shape files. One is the Central Namibia, that is the region where I want to, let's say, focus my attention, and the overlay layer is the multiple polygons that I have in my belt, in the coastal belt along the Namibia zone. I save the result into a file. For example, I call it Central Namibia region. And I do a run. Once finished, you can see that basically I just deselect the previous shape file. Now the Central Namibia region is colored differently from the other, let's say, the belt that you have in the coast along the western coastline of the Africa. simply because I intersected the information with the given shapefile that I have drawn before. Now, the last step is to, let's say, unify all these polygons and make just one unique object. To do this, I again query the vector toolbar. I select the geoprocessing tool, and I use the vsolve function that will take the central Namibia region as so the one in red-orange color, and I create. I save the result into a new file that I call, for example, Central Namibia region merged. I save, I run, and then once it's finished, you see that you have finally a shapefile that have differently from before. When we draw into the bathymetry, now has a meaning. So basically it collects all the cells that have a bathymetric value that is between 8 meters and 300 meters. Now the last step is to load the Copernicus data that I want to analyze, for which I want to do some spatial analysis, really some spatial analysis. So again, I'll use the NetCDF, the CMEMS NetCDF plugin. And in this case, before starting our training, I was downloading from the Marine Data Store the value of temperature at the surface from 1st of May up to the 19th of May. So basically covering also today, but simply to give you, to give to me the opportunity to suggest you, I mean, the powerful way we can exploit the QGIS functionality in doing some monitoring. Because of course the Copernicus Marine service provide not only information about the past ocean, but also forecast data, okay? Not only the reconstruction of what is the sea state in the past, but also a prediction of what will be in the future. And this is extremely important when you want really to make some management of your coastal zone. And this is the reason why, I mean, I found interesting to propose you to analyze, just for matter of brevity, one layer of the temperature field from the 1st of May up to the 19th of May. So today, that is 11, we have the first day, I mean, I downloaded before, so the 11th should be a forecast day up to the 19th. So this, the last part, the last 9 days of this time series are forecast, while before the 11, all these values are analysis. So as yesterday Marie was explaining, is basically the result of the model run once it assimilated also the observation. So we have the best initial condition for our forecasting cycle. Now I need to select basically the time series, and to do that, I need to push Control in the keyboard and select one by one the days that I want to load. I hope that it works, because sometimes, I mean, we will see. I'm a bit scared now about this exercise, but let's do add. Okay, so now all the, as you can see, all the temperature fields from the 1st of May until the 19th of May have been loaded into QGIS. Of course, again, you can modify, customize your palette. You can do really many things with QGIS as we did before. And through the processing toolbox here, I select zonal statistics. So zonal statistics is basically a function that is native in QGIS, that gives to me the opportunity to calculate statistics from raster layers, as in my case are the value of temperature directly loaded from the Siemens NetCDF plugin, and overlapping it, so extracting some information and making some computation once we give to it some vector layer, some vector shapefile, and we have the vector shapefile that we created before. Of course, this can be done if you are in testing mode, you want just to try with one day, you can simply, let's say, fill the information that you have in this first window. Here, for example, is preloaded the raster layer that I want to use, that is the temperature on the 19th of May, and I can give as input layer the central Namibia region merged, so the famous polygon, irregular polygon with merged polygons inside. But since I have more than, I have 19 days to analyze, I would like to exploit the running of the zonal statistics through a batch process. So I do like this. I select run it as a batch process. So it means that the calculation will be done in a loop that basically goes from the first to the last date available in my time series. And this is quite nice because the same logic can be exploited also for other type of functions of QGIS, for doing some, let's say, intersection, for merging, for interpolating, for clipping. You can imagine that the process that we made at the beginning, just with one single file, can be done in a loop through the batch process tool. So here there are some shortcuts that gives to us the opportunity to, let's say, to select in a clever way the input data. In my case, I want to use the central Namibia merged, let's say, shapefile, and I want to select from the open layers the field that I want to analyze. I try to select all of them. I hope that it works properly. Okay. So I selected basically the temperature fields from the 1st to the 19th of May. Now, of course, what I have prescribed for the first day in terms of input layer, I have to do also for the remaining 18 days. So I'll exploit the autofill function, filling down the one-to-one connection between input and raster layer, simply doing a fill down like this. So I basically spread the information related to the central Namibia region merge, that is the input layer, to the other days remaining raster files. The raster band is, we can keep like this because it's how it is coming once it is loaded through the plugin. And as well as the output column prefix, maybe you might be interested, for example, to let's say give a tag to your to the specific let's say statistic that you are computing. In this case, linking it to theta O, but this is a detail. What is nice is that we can select the statistics, and here QGIS gives to you a vast choice of statistics. In our case, since we are interested to monitor the evolution, to have some synthetic information about what might be the mean value of the temperature in that region, or the maximum or the minimum, or the variance itself, I'll select just for among this list of statistics that QGIS provide to me. And again, I need to, let's say, expand it through the whole list of files that I have. The last step is to define the name of the output file. In my case, the rationale here is quite, let's say, again, is quite nice, quite clever in QGIS, because you can simply provide the tag of the file that you, of the file name that you want to create, like in this case, stats. And then in the exact moment you ask to QGIS to save it, it gives to you, recognizing that you have provided to it a list, if the file name of your output file needs to be autofilled somehow with what? Without anything, with some numbers or with the parameter values. I choose the fill with the parameter values because the parameter that I want to use is basically the raster layer, so the name of the raster that I have loaded before. So basically here you can see that this column is automatically filled with, in particular, the target directory that I'm going to, let's say, to use to host the results, and the name will be stats underscore root of the name coming directly from the raster layer, basically. So in this way, I can, let's say, even maintain a sort of coherency between the input and the output information. And now I run, and it is stopped, of course, because it's like this. Okay, no problem. I mean, it stopped because I have most probably many layers opened, but no panic. If I do like this, I can still, let's say, import the results that have been calculated in this exercise. So to visualize them, I create a new subgroup. So let's go in the layer panel, and I create a new group that I call stats, where basically I will load all the results that I have, that the QGIS was able to compute in this first part of the running. Maybe it's still running because but we cannot wait until the end let's say, to complete the calculation, but that is a detail. I mean, I do drag and drop inside this new group of files that I have created. And now let me just, of course, here I have, as you can see, from the 1st of May until the 10th of May, a list of polygons. Each of these polygons is equipped, if you do right click and you open the attribute table, it is equipped with a certain, let's say, number of columns that in this case are related to the mean value, the minimum, the maximum, and the variance. But of course, it's a bit, let's say, complicated to open one by one each of the, in this case, 10 layers, but in the case, once the computation is finished, the 19, let's say, time stamp available. So the last thing that I can do, I mean, of course, QGIS gives to me the opportunity to overcome these difficulties by invoking the data management tool that provides to me the option to merge vector layers like the ones that I have selected. So in this case, I open basically I select basically the results of my zonal statistics process. And I create a file in my working directory that, for example, I call stats final. Okay, so everything should be right. And indeed, once we launch the run and the run is complete, you will see that a new vector layer appears in the left panel in the layer menu. And if you click on, you do right click and you open the attributes table, basically you have the time series from the 1st of May up to the 10th of May, in this case, for the mean value of temperature, the minimum, the maximum, and the variance that is computed in the region of interest. So in this way, we can see basically you can then make some further manipulation or export this table as a CSV format, for example, and open it with a Jupyter notebook as somehow exploiting some of the features that before had been presented by Alvaro, and so making some plots, or I mean, even inside the QGIS, it is possible even to, let's say, create some dedicated plugin, so interface QGIS with Python. And but of course, I mean, being the purpose of this first training, just to give you an overview of what we can do with this kind of software, I mean, we can, let's say, accept that as output we have a table that then the user can export in the format he or she wants. But this simply to, the final message is that thanks to this, let's say, kind of software, we might, we are really facilitated to do some spatial analysis in the regions. And for example, in the user manual, I was also proposing you again for monitoring purposes to select some transects, for example, that can be used as virtual sections for monitoring some key variables. In the user manual is presented the temperature, but that can be also extended to other variables like the chlorophyll, the oxygen, and cross-link any type of data set. So not only the modeling data set that yesterday have been presented by Alice, Marie, and Coralie for the global forecasting systems, but also the observational datasets regarding the sea surface temperature or the ocean color. I mean, you can really have a platform that complement what the MyOcean ProView provides us today as a state-of-the-art for the visualization with some, let's say, more advanced way to compute statistics and make some, let's say, manipulation of your files. So I think that my time is finished, and I thank you for your attention. I'm sorry for this unfortunate color. I'll try to do.
Don't worry, I couldn't interrupt you.
I tried, but you know,
I did see that.
The problem of my. I apologize.
Don't worry.
Not my usual color.
Purple Stefania. We'll have here. Don't worry about that. It gives more color to the workshop.
Yeah, this is the color that that the computer decided.
Yes, don't worry at all. So we do have. Thank you for your presentation. It was really interesting. It's really nice to see also the same topic but in different softwares. We do have some questions for you already.
Okay.
Let me share with you. I have to say, it's you guys are great keeping it for so long. So can you see my screen at the moment? I think you might be able. It's open now. And oh, sorry about that. It's not this one. It's this one. Sorry about that. Bear with me.
No problem. Take your time. Thanks for the patience in also in
not at all. I think I won't be able to share these ones, but I can you can see it right here, right?
Okay.
Oh, I can read it out loud.
Yes,
so which QGIS? Yes, which QGIS version is ideal for altimetry analysis? If there is, I mean,
there is really no constraint in the sense that you can use the QGIS, the last stable version, and I assure you that for matter of time I wasn't able to present, but I opened also sea-level data, and they are perfectly, let's say, georeferenced and visualized in the QGIS. So if you take the last version, the one that is recommended in the Copernicus Marine document, I mean, you in principle, I can tell you that there are no specific problems. Of course, if you face some specific issues, let us know. We can try to support, and eventually we can, let's say, even exploit the community that is around the QGIS, even to, let's say, submit eventually issues that the users might find. I mean, this is the way the community works, and they are very supportive. So in any case, we are here in case if you face some issues with any specific version. But in principle, I can tell you that you can use whatever version you want among the last ones that are, of course.
Yeah. And a second one, can I use ArcGIS to perform this function and achieve the same results?
Absolutely,
can you demonstrate how?
Yes.
Maybe demonstrating will be a bit hard right now, but yes,
yeah,
if you have experience with ArcGIS. Yeah.
The philosophy, I mean, the approach of the geographical information system is always the same. I mean, you know, the GIS works with raster and vectors, so shape files. So basically, the same, let's say, type of analysis and even more that you can do in QGIS, you can do even in ArcGIS. Then it depends on the platform that you want to use.
Great. And one last one, I'm not sure if it's very specific and if you remember this step, Stefania, but is there an equivalent of OSGeo4W for Linux distribution? Was it something you mentioned maybe?
Well, yeah, I mean, from what I know, I mean, I installed QGIS in Windows machine, but there should be also the possibility to install in the Linux distribution. So I guess that maybe we need to find, and eventually we can check what is written also in our guidelines, if there is something very specific for the Linux that might be helpful to be highlighted. But as far as I know, I mean, QGIS can work also in Linux, and of course, I mean, being hosted by the OSGeo4W, you can, let's say, you should be in principle able to install. But let me recheck again, and I'll come back with the proper answer after the training. I mean, we will keep in contact.
Thank you very much, and thank you very much for your presentation as well.
You're welcome. Thank you.
And yes, we have reached the end of this workshop. I hope you will all enjoy it, and as we said it throughout the workshop, you can find all the materials on the Padlet. You will soon also receive an email with some more information and these useful links. Maybe it can be useful to have it all in that email, as some of you have suggested. What else can I tell you? Yes, thank you all for your participation and for your questions. And to all our speakers today, to Anais as well, you're still here. Thank you for your demonstrations. And if you still have questions, you can post them on the Padlet. We have a section where you will be able to post your questions. And if you have any questions throughout your practice, and I hope you will be able to redo these tutorials we had today. And yeah, thank you very much.
Thank you. Thank you all.
Thank you
all.
Bye. Bye-bye.
Thank you. Bye-bye.
Bye.
Bye-bye.